Welcome to Artificial Intelligence Transforming Products and Impacting Safety and Reliability, organized by Center for Advances in Reliability and Safety, CARES. I'm Jen. It's a proud privilege to be asked as an MC at the technical seminar. The speakers of the technical seminars come from different backgrounds and disciplines in pursuit of sharing their knowledge, research findings, and experience on artificial intelligence, transforming products, and impacting safety and reliabilities. Before starts, may I remind the audience that there will be a Q&A sections after the presentations. If you have any questions to raise with our speakers, please mark it down and raise your hands in the Q&A sections. To begin today's program, I would like to invite Professor Winkle Yung, Center Director of CARES, to give us welcome remarks. Professor Yung, please.
Distinguished guests, ladies and gentlemen, good morning. It is my pleasure to extend my warmest regards on behalf of the Center for Advances in Reliability and Safety. We call it CARES, C-A-I-R-S. Now, originally, if you read the agenda, we should have invited Professor H.C. Mann, our Dean of Faculty of Engineering of PolyU, also one of the directors of CARES, to deliver a welcoming speech. However, he has an ad hoc important engagement, so he could not come, so I will deliver the welcoming speech on his behalf. I'm pleased to note that the agenda of today's seminar covers a wide range of very professional and unique presentations and talks relating to product reliability and system safety, using AI solutions, especially those directly applicable to our daily life and in different industries. I would like to take this opportunity to welcome our three speakers from the academia this morning. The first one, Dr. Haibo Hu, the Associate Professor of Department of Electronics and Information Engineering, who will share with us an interesting topic, reliability of machine learning methods. How safe is AI? We never asked this question before, right? How safe is AI? So he will share with us with many applications in our daily life. Professor Edward Chung, Associate Dean in Research, Faculty of Engineering of PolyU, will share with us his research expertise and experience in network-wide traffic volume estimation and prediction, which impacts our transportation in the society. Last but not least, Professor Chow, Dean of Graduate School, the new title for him, and the Chair Professor of Distributed and Mobile Computing, Associate Director of UBDA in PolyU, will address the issue of future edge computing towards distributed intelligence for AIoT applications. And he will illustrate how edge computing leads the transformation on technologies and various applications in infrastructure, in health, in vehicle, and many other systems that directly relate to system safety and reliability. The seminar today is a unique one in a way that it bridges academic research and industrial applications. For this purpose, we have also invited three renowned speakers from the industries in the afternoon section to share their expertise and experience on their applications of AI in transforming their products and in impacting their products' safety and reliability. I'm sure both AM section and afternoon section. Their sharing will bring insights to your business. CARES is initiated by PortU, and our key research collaborator is University of Maryland in USA. We call them UMD. We have 12 professors from PortU who are with research expertise in product reliability and system safety working with us, and 8 professors and researchers from UMD backing us in theoretical research. CARES mission, very simple, is to develop new approaches using AI, algorithms, using industry big data, using data-driven methodologies, together with physics of failures and reliability modeling. At the end, we hope to ensure products reliability and system safety with different applications in robotics, in medical devices, in vehicles, in telecom, consumer products, public utilities, transportation, microelectronics, power devices, sensors, and IoT products. You name them. It encompasses almost every industry. By now, CARES, I'm glad to say, CARES has 15 research projects running in parallel with 24 collaborating companies and enterprises. You will see the list in a banner outside this room. Before I close, I would like to take this opportunity to thank all our collaborating companies and enterprises, supporting organizations, mask sponsor for their participation and contribution, as well as our CARES professional team for the excellent arrangements in organizing this technical seminar, which is not easy. Today, everything goes online. Now we have physical seminar here for the whole day. In fact, we have received over 150 registrations, but on the basis of first come, first serve. So that's why you are here, right? So I hope you enjoy the seminar today, and thank you for your participation, and have a good day. Thank you.
Thank you, Professor Yong. Please remain on stage for presenting certificates of appreciations to our speakers in the morning sections. In the morning sections, we are grateful to have 3 speakers and our mass sponsors. As a token of gratitude, we will have a certificate of appreciation to them. The first one is Dr. Haibo Hu, Associate Professor, Department of Electronic and Information Engineering, the Hong Kong Polytechnic University. Dr. Hu. Yes. Thank you, Dr. Hu. Please wait at the side of the stage for a group photo. Next is Professor Edward Zhong, Associate Dean Research, Faculty of Engineering, the Hong Kong Polytechnic University. Professor Zhong. Yeah. Thank you, Professor Zhong. Please wait aside of the stage for a group photo. The third one is Professor Chao Jingnong, Dean of Graduate School, Chair Professors of Distributed and Mobile Computing, Associate Directors of UBDA, the Hong Kong Polytechnic University. Thank you, Professor Chao. Please wait at the side of the stage. Everyone gets your souvenir at the reception, right? I would like to invite our mass sponsor, Ms. Gigi Ng, consultants of Greenlane Global Limited, to come on the stage to accept the presenting certificates of appreciations. Could Professor Yung and Ms. Gigi kindly remain on the stage? And let's invite Dr. Hu, Professor Zhong, and Professor Chao to come on the stage again and take a group photo. May I also invite Dr. Humphrey Learned, our Vice Chairman of HKEIA, and Mr. Basil White, CEO of HKEIA, to take a group photo too. Thank you, other guests. Please be seated. Dr. Hu, please remain on the stage. The first speakers of this section is Dr. Haibo Hu, Associate Professor, Department of Electronic and Information Engineering, the Hong Kong Polytechnic University. The topic of Dr. Hu's presentations is reliability of machine learning models. How safe is AI? Please welcome Dr. Hu.
So I have my timer on, so just in case okay. So thank you, and thank you for the invitation from Professor Yung, and thank you all for coming to this very exciting whole day seminar. And well, I'm Da Hu from Department of Electronic and Information Engineering, and well, I think the topic today, as Professor Yung just mentioned, is a little bit sidetracked. Okay, so it's talking about the reliability of AI itself. Okay, rather than talk about how AI can improve our reliability and safety, which will be the whole theme of today's seminar. We have a strong team of guest speakers. We talk about that. So that's the main course, and hopefully I'm just the appetite. And I talk about something else, which is another side of the story. So about how safe is AI. So my talk will consist of 3 parts. So the first part, as Professor said, I will give you a lot of interesting applications, how severe the safety of AI is right now. And then I will talk about the actual theoretical attacks that are actually happening in all kinds of AI systems. And in the end, I will talk about the defense schemes. Right, so without further ado, let me start to introduce you with some very strong and very thrilling cases right now happening. Okay, so actually we know about that already. Tesla, which is a very popular and very high market value company right now doing autonomous vehicles. And well, normally it can appear in the newspaper in 2 different kinds of scenarios. One is that their market value has been outwin Toyota or any other traditional car companies. But some other cases, they appear in the headlines of the newspaper is that their cars has something wrong. And very recently, last month, actually a car accident happened in Texas, US, and 2 men were killed. And well, people are now rather anxious about what happened and concerned. So actually, their CEO, Musk, actually immediately sent a tweet in the Twitter and said, okay, it has nothing to do with the safety of Tesla cars, because at that time, the autopilot system, which is actually, according to SAE classification, is a level 2 system, which require human involvement, and it is not on. But unfortunately, later on, actually, the Tesla VP engineering actually mentioned in the testimonial that actually at least one of the autopilot's features, which is related to autonomous driving, is called adaptive cruise control, is on. Well, actually, this case is still under investigation, so I cannot comment or give you more information. But at least you know that actually, this car accident has something to do with the safety and reliability of their AI-driven systems. And my second case was that actually, this is also related to a very famous company, which you might see in the news headlines, called Deepmind, right? The Deepmind has invented a lot of AI systems, like they can be in the chess games, right? They can outwin a lot of human brains. And also, 2 years ago, actually, they proposed and they have created an AI-based diagnosis system, which actually can help the hospitals to predict whether their patient can have those acute kidney failure with a 2-day time frame, which means that they can predict whether this patient will develop this kind of syndrome in advance, okay? But, well, actually, they boasted a lot in their publicities, but actually, in a Nature paper, which was later published by their users, actually claimed that this system is not very reliable. And in fact, for every correct result, they will produce at least 2 false alarms. Well, these kind of false alarms, which means that the patient eventually did not develop any kind of syndrome, but actually the AI system predicted. This will cause a lot of side effect because their medical team will give those a lot of dose to prevent this kind of thing from happening. So this is kind of overdiagnosis will be harmful to the patient. Okay, so this is about the AI safety in the medicine. And third thing, of course, a lot of AI applications has been developed in financial systems as well, especially for the fraud detection. Actually, there's a recent survey from this company said that actually for all the financial institutions, they have surveyed a majority of those institutions right now are using the AI systems to do fraud detection, which means that they can, based on your track record, to detect whether your current credit card transaction is a fraud or actually is made by you, right? Based on your behavior, what kind of things that you normally buy and where this transaction is happening. Okay, so actually, this is very important, as they say, to do the fraud detection. But unfortunately, a recent paper in Usenix Security last year have told us another side of the story, which means that actually this kind of fraud detection can be easily circumvented by those hackers by doing what we call the evasions, which means that as long as this model is publicly known, which means that we all know what kind of AI models they are using, and they're just different from the parameters, and then at least 60% or even up to 100%, these fraud detection can fail by doing a small perturbation on the input samples. Okay, so I will talk about this model invasion later on in the attacks. So all in all, we can know that AI safety is serious because right now a lot of things are based on the AI systems. Right now, just like maybe 20 years ago, we start to base our business on the software, on the internet. Right now, we are based our business or daily life on the AI systems. So we are not just sitting there. Okay, so a lot of companies, like here, like this is from the Gartner. So actually, Gartner has proposed a very comprehensive framework for the cybersecurity. And actually, you can see right now they put in the bottom 2 kind of operations that are actually involved in AI. So one is, both of them are called model ops, so the model operations. It's not just IT ops or network ops, it's now the model operations, so which means that we're not just creating a machine learning model and then deploy it and it's done. It's not the end of the story. We have to do the daily operations, how to do the monitoring and the improvement. So one thing is about the model itself, the integrity of the AI model. And another thing is about the integrity of the AI data, which means that the testing data and the training data for the AI systems. This is because all these techniques, which I will try to cover some of them, will help us to prevent the attacks here. As you can see, there are a lot of attacks. Of course, some of the attacks are very traditional, like the network intrusions, the data can be theft by those adversaries from hackers. But right now, we have some different categories of attacks, like doing the AI model attacks or the data model attacks, which I will cover in the the second part of my talk. All right, and also Microsoft recently, actually it's this month, also released a very powerful product, which is called this counterfeit. Okay, so actually this is their in-house built system, automated system for doing, it's just like doing a vulnerability scanning. But now you're not doing vulnerability scanning for your web system or for your database system. Right now you're doing vulnerability scanning for your AI systems. Actually, it's a very premature AI it's a command line tool, but actually this is a very big step towards their commission for those what we call the responsible AI. So for a large company like Microsoft, they produce a lot of AI systems, especially in their Azure cloud service. Actually, they need to ensure that customers they are enjoying a reliable and safe AI systems. Okay, so that I hope that my introduction on the applications or the cases of this AI safety can arouse you the interest on what's going on right in the AI system right now. So my second part, I'll try to talk about the actual research which has been happening in the academia to talk about how we can undermine the AI systems. Okay, so first of all, I would like to give you some very simple definitions. Okay, so in academia, we call this kind of undermining techniques for machine learning, it's called adversarial machine learning. So basically, adversarial machine learning is just like doing hacking on the software. We just try to undermine or subverting machine learning system for fun. But of course, for some other professional hackers, they are doing it for profit. Okay, so before I talk about how we can attack a machine learning system, first of all, let's give you an outline. Okay, so if you're not very familiar with a machine learning system, so what is a machine learning system? Okay, so here, this is a big picture of a diagram on the flow of the machine learning system. So right now, if you want to build a machine learning system, first of all, you need to pick like a machine learning framework, right? So like you can use PyTorch or TensorFlow or Keras or whatever systems right now, because normally you are not building it on yourself, right, from scratch. And now, after that, of course, you have the system and you need to have data, right? You have training data. You collect the training data. Hopefully, they are labeled and cleaned. And then you use the framework and choose the training algorithms you prefer and the training parameters you prefer and select the models you want to build. And then eventually, after a lot of time, of course, then you can get a model, right? And then this model can be deployed on your server, on your edge, like Professor how we mentioned about edge computing, on your edge system, mobile systems. And after that, whenever you have some other testing data, right? Testing data, or the real data case, like an image from the outside, and then you can put back to the training model, and this training model will tell you some function. Okay, normally it's a classification. It's just tell you, like you give an image, it can tell you whether the subject of this image is a dog or cat, right? As simple as that. Okay, so it will give you a label. Normally it's a label, or sometimes it's more complicated. It's give you a vector of the output telling you like it's like maybe 60% likelihood it's a dog, right? And 40% is a cat. something like that. So this is normally a conventional machine learning system. Okay, so now let's see what can be wrong. Okay, so technically speaking, what is the attack surface for us to attack, for the hacker to attack? The first attack surface is from the inference perspective, which means that the attacker will try to compromise the whole inference process. Okay, so basically this part is that the attacker will try to make your model to predicting something wrong. For example, like supposedly you have an image, right? So this image output should be a dog, right? But somehow he can just manipulate it or to add some noise or whatever and to make it looks still like a dog, but model will predict it as a cat. Okay, so this will undermine a lot of AI systems, like especially like autonomous driving, right? Because a lot of autonomous driving are based on computer vision. So we need to recognize the object, especially those traffic signs, correctly, right? If the traffic sign is still correct, but the recognition is wrong, then that will be very disastrous error happening. Okay, so this is from the inference side. So another attack surface is, of course, the opposite from the training side, which means that the attacker can try to poison some of the training data, and hopefully your trained model will be something different from what the user has expected. Taking the same application scenario, like autonomous driving, right? So if the model itself is already poisoned, it's just like a software has a virus inside it, which means that it will not malfunction immediately, but maybe after some time, in the input there could be some trigger, which means that if there is a small tag maybe on this image, and then the output will be wrong. And that's where the attacker will try to launch the attack. It's like a virus, right? Normally the software is still working, but maybe after one single day or whenever this hacker give you this command, and then your software stop to work, right? So this is also very dangerous. So this is normally we call a data poisoning to try to jeopardize the model. And the third attack surface is trying to actually to compromise the whole thing that is deployed on the client side. So this is we have assumption that in this case the model itself has been deployed on a client system. If it's on the server side, it's on the cloud service, then we cannot do that because we cannot have a control, right, of this model. But if it's on the client side, then normally we can do a lot of attacks, like we can steal the model. Okay, so right now the model is a property of the company and actually the most important asset of the company. So what if we can actually make a duplication, a single replica of this model, right, and try to jeopardize the company's asset value. And also we can do some other things, like we can even try to invert the model. So normally we know data becomes model, right? Model inversion means that we have the model, then we invert back, we can get the data. This will seriously compromise the privacy. Okay, I will show you some cases. And similarly, we can do same thing. We have the model, and we can tell which data is in the training set, which data is not in the training set. This is also a compromise of the model, of the user data, privacy. Okay, so let me give you very quick examples. And the first is about, as I said, the first attack surface is try to make your inference incorrect. Okay, so this attack in academia we call it a adversarial sample, or sometimes we call model evasion. So here is a very classic paper and a classic case, which by Gold Fellow. So actually, in about 5 years ago, they talk about adversary samples, and what they're trying to do is trying to add some noise, put some overlay on an image. Okay, so this is not random noise, but this noise is quite difficult for human to spot, and overlay it on a normal image. And the output is very astonishing. Actually, they have compromised this pre-trained image recognition system, and normally the system can predict that this image is a panda with more than 50% of the accuracy. But after that, this image recognizer can only predict that this image is a kind of an ape, a small ape, a gibbon, with almost 100% of accuracy. So which means that we can tilt the output of the recognition result very easily. But human cannot detect, right? If you see this image, you still believe this is a normal image. There's nothing wrong. It's not poisoned, right? So this is very dangerous, as I said, especially in autonomous driving or in any system that are based on computer vision. Okay, actually, model evasion means that, like, if this is a suspect, supposedly he should be recognized, right? But if he put a mask or put whatever some glasses which can evade, actually, I will show you in the next. Okay, so this is what I talk about. We cannot just do it on normal images. We can do it the same attack on face recognition. As you can see, this is what we call the target label, right? This is the guy, this is the subject we want to pretend to be, right? And then this is the base image. So this is what we have, okay? So we want this image to make some changes on this image. So for this face recognizer to believe that this image is this guy, and this image is this guy, belongs to this guy. Okay, so actually you can see the result. I will not go into the technical details on how we can achieve that, but actually you can see we can do different types of algorithms. Basically, you can see like this one, right? This one has very high accuracy. Of course, your image will be a little bit blurred because we add some noise and we also do some post-processing. And all these images will have very high confidence that they will be classified as the target person, not the original base person. Okay, so this, in other words, we can actually plate this face recognizers and in a very high confidence. By the way, doing attacks may not necessarily means that it's bad. Actually, we use the same technique. We can do some good things. Actually, I'm not sure whether you know it or not. Actually, a lot of face recognition system actually are crawling the internet to trying to use our photos. Normally, you send it to Facebook, right, or Instagram, post a lot of photos. And these photos are actually being utilized by these companies to build up their own human face database. Of course, we don't want that, but because our image are uploaded by ourselves, right, we cannot have control of it. So actually, this was also in last year's Unix security conference. They proposed a very simple technique. Whenever you upload your image, you use their tool to do some post-processing. Okay, actually, you can see the output, what they call the cloud image, is still the same. From human eye, it's still the same image, right? Same quality of image. But this image has been tricked with some noise. And this noise, even if for those attackers who will try to track you, it will still mislabel it. So in other words, after that, whenever you upload any image to Facebook, even if the hackers read that, load that image to their system and try to train it, it can still not know whether it's you or not. Unless, of course, unless you claim that this is my image, right? So this is very, very useful for your privacy. Okay, so sometimes adversarial learning, machine learning can actually help do some good things. And this is also related to computer vision, which we can do adversarial examples for object detection. So this is happened in DEF CON 2 years ago. Actually, it's a team by Baidu. they have produced a T-shirt called Stealth T-shirt, which means that once you wear that T-shirt, you will be invisible to some object detector. These object detectors are normally just deployed in the IP camera, right? The surveillance cameras. They will not recognize you as a human, okay? So actually, they will just demo that, okay? So from the left-hand side, you can see once he shows this whole T-shirt, there's no green box, right? Which means that the detector does not see him as a person. But once he blocks this tag, actually the detector will see it. So which means that the trick is in the tag. Actually, you can see this tag, right? So they put on this tag, and then this box will be gone. So which means that the tag can actually make you stealth in this surveillance camera. Okay, so this is also what we do for adversarial examples for object detection. All right, so now I talk about another part, how we can poison the training phases. Okay, we can poison the data to the training phases. There's some very typical example, like in 5 years ago, we know that actually Microsoft has developed what they call the AI chatbot, which means that you can chat with him. And actually, he is not a pre-trained model, which means that he will learn more things whenever you start to chat with him. So actually, Microsoft invite from the tweeters to actually to participate. So actually, it's very good. But in fact, after 24 hours, this bot has become let's say a racist with a lot of bad words. Okay, so this means that we can actually poison data to make this data to become something that we want him to be. Okay, and here I will try to give you some idea on how we can do this data poisoning. Okay, so suppose that we have the original model, right? We have two classes, right? So this is one class A, and this is the class B, and this is what we call the target class. We target on try to compromise this class, and this is what we call the base class, which we have this data, right? So basically, the data poisoning, we try to create some what we call the poison data here. These kind of data are somewhere in between these two classes. Okay? Of course, you do one poison data, you just pull a little bit from this class boundary to this side, right? Of course, one poison data is not enough. If you have a lot of these poison data, and the whole class of the boundary will be dragged to the base class. So that, of course, this is not as simple as that, but actually this is the main idea of why and how we do the data poisoning. Okay, and actually this is what I mentioned about the autonomous vehicles, like the computer vision, actually can be poisoned very easily. Like as you can see, this is the real examples, and when it's supposed to be a sign of stop, but actually this once we have this small tag output, it will be recognized as speed limit. Okay, so this is very dangerous. Okay, I think I can skip some of that. And lastly, for the attack, I'll talk some of the work I've done. So as I said, in the final type, we have this machine learning model deployed on our device. And then we'll try to steal it. Okay, so I'll show how we can steal it. And our target is on the Google on-device automatic speech recognition system. So basically, this Google on-device ASR has been deployed once, but it will be everywhere. Your Google Assistant, your Google Map, your Gboard, all use the same model, actually. And this model is very small, actually. So normally, a normal ASR model should be 100 gigabyte large. But Google have made it distilled to be only 450 megabyte. And in the compressed version, it's only 50 megabytes. So this 50 megabyte is what we want to extract. And this is our framework for the extraction. And I don't have the time to talk about details. And we try to feed the Google Assistant with these two data sets, and eventually we can have around, well, 70%, I should say. If we have more data, we can even reach, as you can see, the more data we have, the lower the error rate, actually. So right now we can have 30% of error rate, but once we have more data, actually it can slow down. And the whole process is automatic, so we just need some time, okay, and then it will be done. Okay, and finally, the attack is model inversion, and this is also very dangerous. As I said, you move from model, you can go back to the data. So how clear it is. So this is the original training data. And of course, we don't have that, right? So for the model, if we have the model and we keep asking for the same sample and see the output of change of the output of the labels, we can get back something like that, something like that. And even in the best case can be something like that, which means that the whole privacy of training data can be compromised. Okay, so I think I probably have run out of time. So I will skip some other attacks. I talk about the protection techniques. So there are a lot of ways to do the protection. Of course, the most traditional way is try to detect who is doing the attack, right? So we do the outlier detections, but this is not enough. And actually, there is, if you are an engineer and you are concerned that your AI system can be compromised, this is what I suggest. You can do what we call adversary training, which means that if you know there are some adversary sample, then actually you can reuse these adversary sample to train your system again. Oops, to train it again, and then your system will be robust. Of course, when you train it, you should use the correct label, not the wrong label. In other words, if you know the adversary sample in advance, you can make your AI system robust. So this is one takeaway message. But in the end, I should give you this one. I would skip my defense. And okay, so this is what I want to mention. Unfortunately, all the defense have limitations. There are two sides of the same coin, which means that this is a machine learning model, okay? So if you have a overfitting problem, your model is too specific. If you have an underfitting model, your model is too general, right? But unfortunately, the attacks can happen in both extremes, which means that if even if you have overfitting, you will see some attack. If your model is very general, you will see some other attacks. So there's no one-size-fits-all solution for the defense. Okay? So this is my final conclusions. So machine learning model can be very easily to be generalized in all stages. And unfortunately, there's no global solution to address all the attacks, because we can always exploit some of the vulnerabilities of the machine learning model. But if you know your model well and you know your attack well, you can always create some local solutions that can prevent from these attacks from happening. Okay, so that's all for my talk. Thank you.
Thank you, Dr. Hu. Thank you for your presentations. Please be seated. Our next speaker is Professor Everett Zhong, Associate Dean, Research, Faculty of Engineering, the Hong Kong Polytechnic University. The topic of Professor Zhong's presentation today is network-wide traffic volume estimations and predictions. Professor Zhong, please.
Okay, thank you. So today I'm going to talk about network-wide traffic volume estimation and prediction, a change of pace from Dr. Hu. Every one of us travel. I mean, for example, today we all travel to the science park, and we pass through a number of signalized intersections. So that makes kind of every one of us an expert in transport. But to make the traffic signals work, many of us may not be aware that there are actually sensors installed on at the traffic intersections. The sensors are used to collect the presence of a vehicle or count the number of vehicles. And why do we need to count the number of vehicles? It's because when we know the number of vehicles, or i.e. the demand, then we know the signal controller knows how to set the timings, how much okay, no problem. So how much green time is should be allocated for each site, right? And also we need to know the presence, because sometimes, let's say a right turning slot, there's no cars, then we can skip the phase, so we do not need to have a right turning phase, right? So that's needed. And of course, we often assume that the detectors are always working. Hence, what's kind of relevant to this case is about the reliability of the sensors and of the systems. And in actual fact, it's not always reliable, either because there's communication issues or the detector is not working. So they are not working all the time. Let me go to the next one. So in terms of control for the real-time traffic management, so not only we want to know how many vehicles that we have counted, but what would be very good if we know what the traffic volume is going to be in the next couple of minutes, in the next 5 minutes or so. So if you know the traffic volume, then you can proactively plan your signal, so you can have a more optimal settings for that. So hence, the traffic predictions is important. When we have detectors failures, then what happened in that case is that this traffic signal controllers doesn't know what to do, because there is no volume. So how much time should we give to that approach, right? So we don't know. So typically what a signal controller would do is that it would switch back to a default value. The default value would be a setting that has been set when the signals are installed, and it's hardly retuned, right? So the net effect would be that, let's suppose one of the detectors is not working, and the signal controller would use a default setting, and often it would be very conservative. So you result in a long delay for the approach. So there's no vehicles, you still let the time green, right? Because if you get too short a green time, then the queues will be accumulating. So that's actually not very good. So without a better alternative, you would set it to a very long time, and that makes the system very ineffective. Sometimes, when we request for data, either for studies or for research, we often have this missing data. So we need to kind of impute what this missing data could be. So if we could find a way to fill up this missing data, that would be a good things to complete the whole data sets. And often when we look at online and offline application, we don't look at just one detectors. We look at an area or the whole network as a whole. Okay, so that's where this work is related to. So the application of machine learning in the transport area is not new. Often in the past, people look at only one detector, or one intersections, or small corridors. But what we like to do is to look at the whole city and to estimate the traffic volume and predict the volume in one go. And a lot of work that doesn't look at the cases where when the detector is not working. So they assume that detectors are working, this is how we're going to control the signals. But in reality, detectors are not working all the time. So missing data or failure of detectors. So if you look at, so this is the data from Japan. I will talk a bit more about the data later. So this is for the city of Tokyo. And if you look at, and for that particular data, we have data for every 5 minutes for every detectors. And if you look at across the whole of Tokyo, and if you want to look at a time slice, let's say 8 o'clock in the morning, what percentage of time slice that you can have all the detectors working? There's only 0.5%, because sometimes some detectors are not working, sometimes you don't have communication. And if you are happy with just one time slice missing, you only get 3.1%. So as you can see from the graphs here, there are very, very few time slices that you can have complete data set for the whole network. So that has an implication in terms of how you want to train your model for the network, right? So to have a complete data sets For training, then you would have a very small data, even though you collect it for a year. So the question is, how do we make a better use of the data? If you look at the failure rate for the whole network, the failure rate is about roughly, so this is for the whole year, for last year, 2020, it's about 4%. And that's quite typical, whether the type of, regardless of the type of sensors that you use. By the way, in Tokyo, they use ultrasound sensors. Other places, they would use a loop detector. And if you look at the average failure rate by day of the week, it's about, say about 3%. And what we do not really know is why on the weekend it seems that the detectors are on holiday as well. So that's something interesting. A typical detector that you see, that it hardly runs at 100%. It's not 100% reliable. Most of the time it's because of communication. They're running about 90–95% throughout the day. So this is a typical detector for 2020. So, and then if you look at detectors that are working all the time, the available time slice, again, they are very small. So I guess the message here is that we cannot have 100% of the detectors working or 100% of the time slice that we have data and to train our network. So, and we want to look at, can we train a model to tell us what the traffic volume should be when the detector actually failed. Okay, so that's the goal. So we have, just a remark is what I've just mentioned, very little data where all the detectors are working, and then we need to impute a few time slices so that we can fill up, we have more data for training. So to do that, we look at, we use Tokyo Metropolis data. They have about 1,400 detectors, which they use to control their traffic. And we use the year 2020 data, and that's the data that we use. It comes with every 5 minutes, and they release the data. By the way, the traffic signal controls in Japan is controlled by the police agency, and they release the data every month. So we get the traffic volumes, as mentioned, every 5 minutes, and they have the detector numbers, link numbers, and the distance from the stop line. So basically, they have an ID so that you can know the locations of the detectors, how they are related to other links. So we could, there are a couple of approaches we could train our model. That one of the ways is to train just every single detector as a model, which would take a very long time. Or we could treat the whole metropolis as one single entity, one single clusters, and we train the model that way. The disadvantage of that, of course, is that we don't have a lot of data to train because there will be lots of missing data. Or we could make them into smaller clusters, and when you have small clusters, the data availability increases quite significantly. So if we use the single detector, then we have, basically we have 1,400 models. It would take a very long training time. If we cluster them, then if we just use as one cluster, there's not much data for us to train. If you do clusters, you have more data. But I think the advantage of the second and third approach is that we can actually have the spatial and temporal relationship which you can build from the model that way. Okay, so we did some very simple clustering by distance and by adjacency. So the detectors that are close to one another, we would group them together, or they are adjacent to one another. Adjacency and distance are not necessarily the same because let's say some detectors are divided by, across the river, so north of the river, south of the river. Distance-wise, they may be very close, but they are not really linked to one another. so we can divide them into clusters. So the clusters that we came up with is about the 20 clusters that we have here for Tokyo. So basically the main downtown Tokyo is over here, and the rest are the greater Tokyo metropolis. So we then, after the training for the 20 clusters, we also train the single clusters. We look at some of the inputs. The most important inputs would be the day of the week, the hour, the time of the day, and then the traffic volumes, some historical traffic volumes. What we wanted to output is to predict or to estimate what, first of all, to predict what the next time interval would be, or next 3 times interval would be. And we just use a fully connected neural network for this. The rest of the technical details are not important, so this is basically to show that we use a fully connected neural network to train 3 times interval, next time interval, and then next time 2 times interval. So if you look at traffic predictions, so we divide them into 5, 10, 15 minutes as a short time prediction, and then a medium prediction horizon and long time prediction horizon. So why do we do that is that for traffic signal control, you would be looking at only about 5-10 minutes, right? So unless you're doing a longer planning, then you would need to look at the longer time horizon. And of course, the accuracy drops as the time horizon increases. So first, we look at some results. The traffic volume prediction for predicting the next 5 minutes. And this is just picking one of the detectors, detector number 10. The top graphs here shows the single entity, as in you treat the whole of Tokyo as one. And then the bottom one is if you divide them into clusters. You see that the results are very, very similar. But only that probably there's more wiggly in the multi-clusters compared to the single clusters. So in terms of accuracy, it's pretty good. The blue lines are actual measured ones. You can see that the volumes are not very smooth. So one 5 minutes you might get a fairly high volumes. Next one you get a little bit lower. And we do not smooth the volume in our training. If you look at the for one, sorry, let me go back a bit. So this is over multiple days. Right? So this is over a week. The next one is over just for a day. This is what you look like. Again, the results between the two would be very similar. If we want to predict the traffic volume a bit longer, for the next 5, 10, and 15 minutes, and you see that the accuracy for, if you use the just treating them as one cluster, this is the mean absolute error that you see that that if you treat them as a single cluster, it's not as accurate as treating them as multiple clusters. Okay, so that's the results from here. Another interesting to note is that because we have the output is over 3 time intervals. So if you see that for the first time step when you get an output versus if you use the predicted values to predict 2 steps later, that's less accurate than just the first level of prediction here. This is because the error tends to accumulate over time. So this is about a prediction, right? So we look at the 5 minutes, 10 minutes, 15 minutes prediction. So what happens if we have a detector that failed? So if the detector doesn't give you any readings, but you want to know what that volume should be. So what we did was that we test detectors. We actually have the traffic volume for that detector, but we assume that we do not know anything, so that therefore we have a ground truth to compare. So we start the day with a 0 volume for that detector, assuming that nothing happens. So what the output is going to be. And then we can compare that estimated volume versus versus what's the actual volume, which we do know. So we selected 2 detectors randomly. One is in here in Tokyo, 674. This is because it's in Tokyo, the traffic volumes are very high. So this is on the outskirts, and 121, 1212. The detector volume is very small. So we're looking at, okay, well, what happens, to the prediction for very critical detectors versus one which is, plays a very little role in the whole control system. So that's the 2 that we are testing. So first of all, if you look at the very low volume ones, the way to read this is that this is the single clusters, this is for the multiple clusters, and the bottom one here is when we predict the volumes where the detector is not do not fail, and this is when you start the predictions assuming that you get a 0 input, and what's the output that you get. So the y-axis is the mean absolute error, so this is a measure of accuracy. Of course, if you compare this without failure and with failure, the with failure gives you a higher degree of error, which is understandable. This is for a single detector accuracy. This is assuming that there's no failure. But if you look at just a single detector itself, when there is a failure, you can see that the error is so much higher. So single detector definitely is not the way to go. But treating the whole city as one single clusters or multi-clusters are much better. Next, we look at the very high volume detector when it failed. What happens? And you see some kind of very interesting. Interesting results, which is that for a multi-cluster in this case, so this is without failure, the result is actually better than the single clusters. But when there is a failure, the multi-clusters, the error rate is actually much higher, much higher. So the question then is, why is it performing so badly? What we think is that because the cluster is very small, well, it's smaller than the whole network. So it loses the spatial relationship that could be obtained from one single cluster. So in the single clusters, you know what the neighboring clusters are performing in terms of time and space. So you can draw that relationship. That relationship. Whereas when you have a cluster, a single cluster, or smaller clusters, when you have one very critical detectors that fail, so you lose that kind of relationship and your prediction error increases. Right? So in terms of us moving forward would be how can you have a smaller clusters but also capture the relationship with other neighboring clusters. So that would be the way to go to improve the model. This is not, that doesn't tell us anything different, which is that single detectors model is not the way to go. Then we look at a more realistic situation where every day, as you know, often we have failures, right? So it's not just one detector that fell. You have 10, 20, 50 detectors. So we simulated that situation. And you can see that for the multi-cluster situation, this is the results for the whole network, is that overall the multi-cluster situation when there's lots of failures is performing better than a single cluster. That's the message that you can get from this graph. So obviously the more the cluster failures, the less accurate the whole network prediction will be. So this is that makes sense. So what we can conclude from this is that obviously if you treat the whole city as one cluster to train your model, we don't have really enough data to train because of miscommunication or data failures. And so when you cluster the city into smaller groups, then in that smaller groups, your chances of having a bigger training set data is much better. Obviously, clearly shows that the single detector is not performing very well. That's not the way to go. And what what else can we say? Yes, and what we found is that when even for small clusters, when you have a detector that fell, a very critical detector that fell, it loses the spatial and temporal relationship with other classes that is not captured in our current model. So we need to find a way to capture that. And I think that's the way to improve our model. And with that, thank you very much.
Thank you, Professor Chung. Thanks for your sharing. Please be seated. Ladies and gentlemen, there is now a break of 5 minutes. Please take your belongings with you when you leave. When you come back after the break, we will have one more presentations and a Q&A sections in this morning. If you have any questions to raise for the speakers, please drop it down and raise your hands during Q&A sections. The conference will start after the break at 11. After 5 minutes, 11:15. Thank you. Our next speaker is Professor Cao Jinlong, Dean of Graduate School, Chair Professors of Distributed and Mobile Computing, Associate Director of UBDA, the Hong Kong Polytechnic University. Professor Cao will speak on the topic of future edge computing towards distributed intelligence for AIoT applications. Let's welcome Professor Cao.
Thank you. Thank Professor Yung for the very kind invitation. So I'm very pleased here. Like to share with you about the progress in the edge computing technologies. So you can see I'm talking about the future edge computing. That means edge computing has been there over the past several years, but what will be the future? Okay, so it's towards more distributed intelligence. So I will talk about starting with the cloud computing. I think everyone knows cloud computing in the past decades. It has been the center, and all the organizations, industries actually rely on the cloud computing for business transformation, innovation, right, and all the things. And the major advantages of cloud computing actually are the resource pooling. So you do not have to build your own data center, and you can rely on all the rich resources available on the in the cloud and centers, and also some business models, right? So you pay as you need, rather than that said I need to actually reserve certain number of servers. No matter I use them or not, I need to pay. But in cloud computing, they have this called on-demand services. I need one server, I pay only for one server. I need suddenly peak time, I need 100 servers, and I pay for 100 servers. And so this is also called elasticity, so it can go up and shrink, as easy as you want, and also very reliable. So in the past decades, and the cloud computing has been the main driving forces for the organizations and for also the industries. But actually, you can see cloud computing, although have many different kind of applications, but it's not good enough for one particular kind of application. It's called IoT, okay, Industry of Things. And you see the model for the central cloud. Everything you collected, right, the data, and you have to send back to the center, and then for doing processing, for doing data analytics and making decisions, and then the result will be sent back. But for IoT, you know that we have huge number of sensors, right, collecting a lot of data, and then you need to send all the data to the central cloud, and then you need to wait, right? At the end, you will see the center, the data center is probably thousands of miles away from us. I mean, for Hong Kong, maybe you have a data center, but for some countries, the data center is located, far away, and then you have quite a long delay, and you have a lot of demand on the electrical bandwidths, and then that actually causes a lot of problems for IoT applications. IoT mostly called real-time applications, right? You need the real-time decision and then control feedback immediately for your, for example, manufacturing or healthcare and all this kind of, we call the time-critical applications. So let's just look at the IoT evolution. At the very beginning, probably it's okay, 20 years ago, you know, Kevin Ashton is the first one actually coined this term IoT. He was actually an engineer from UK, and then he become a brand officer of a company, and then that actually leads him to the interest of the RFID technology. By that time, RFID is very, very advanced sensoring technology, and that actually leads to go to MIT, set up what's called an Auto ID Center, and then that's the first time RFID technology has been standardized. And then he said that IoT probably will be similar as internet. By that time, internet, you know, getting very hot. And he said IoT probably will be even better than IoT in the sense that it will actually revolutionize the whole industry in terms of you can, you know, sense and connect all the devices together, and you can monitor, you can diagnose. And then he said that would be actually amazing technologies, right? So when the IoT comes out 20 years ago, it's just, you know, RFID sensors, and then you connect devices, and then you collect the data, then you can do some diagnosis and control. But you can see as the evolution of the IoT goes, today, IoT has been a very rich network connecting many of the devices, even our human bodies, and with all different kinds of sensors, not only RFID sensors. And then you collect the data, not only for diagnosis and monitoring, you can do, you know, big data analytics, machine learning, you can predict, you can do a lot of advanced processing rather than just for the monitoring things. And it has been used not only for smart homes, it has been used for, you know, large scale like smart cities, and also for engineering applications, like, you know, you can monitor, you can diagnose bridges, high buildings, and you know, all the including also the human bodies. So IoT has been evolved, and we have many actually different kinds of new applications. But you can see in the past 20 years, IoT developments have been focused on mostly sensing, right? You know, all the sensing I just mentioned, that not only RFID at the very beginning, and also wireless sensor networks actually have been there for more than 10 or 15 years, and have been used for monitoring environment and monitoring, as I said, the transportation, and also engineering high buildings, etc., and then also monitoring our human bodies. And then for the networking, we also see a very fast development. Actually, I remember when I taught the first time mobile computing wireless network in PolyU, it's still 3G. 3G by that time was, you know, very fancy technologies, but today nobody talk about 3G, right? Nobody talk about 4G. We're talking about 5G and 6G now. And then we also look at all the seamless integration of different kind of networks. So you can see network of different kinds can be integrated. And today people talking about so-called cross-technology communications, for example, Wi-Fi and Bluetooth, and then they can also actually, RFID, they can actually intercooperate without even the need of a gateway. Okay, so they can intercooperate at the protocol level, and that actually expands a lot of interconnections of IoT devices. Massive number of devices can be connected. Application-wise, we see many, you know, IoT applications. I think you heard about smart homes, retail, and all the things. But as I said, most is still focusing on the operational issues and also for monitoring and diagnosis. Intelligence are there, but still very limited, mostly for like smart home things, through interaction and they learn the human habits and then try to be smarter. But in the past 2 or 3 years, we see emerging advanced IoT applications. I just give some examples. The first one, video surveillance, right? Large scale, cover large areas, but that involves real time and privacy preserving, right? And also collaborative, means you have multiple cameras that actually cover large areas and then make it advantages of the locality and also correlations, and then they can actually do a lot of collaborative video surveillance applications. And the industrial IoT becomes very hot. So today, actually, we'll see the future of IoT technologies will focus on industry scale. So that actually covers process operations, predictive maintenance, rather than just monitoring and also diagnoses, and also operation optimizations. That also includes smart manufacturing, right? And then you look at autonomous driving, and actually now we already have some companies that can provide the level 4, autonomous driving, most fully automatic. So in some companies, autonomous driving in China, they already have this, public taxi for you to hire. So you can just hire autonomous driving taxi, and now they are actually pushing for the public buses, okay. And then for VR, AR, it's getting more immersive. So that have been used not only for fancy demonstrations, but for industry, for education, and all different kind of things. But if we'll see, the common features of this kind of applications are real time, right? Very low delay, high reliability, and intelligence. So today's IoT probably can still not satisfy, and today's central cloud model cannot satisfy. I already mentioned about this. So you can see now people are actually talking about so-called edge computing, but edge computing is a part of this so-called distributed cloud. So distributed cloud means what? Means you have combinations of traditional central cloud and then hybrid cloud. Hybrid cloud means you can have your local enterprise data center combined with the public, and push further, then you can have this edge computing. Edge computing actually simply says that we will place the application's resources to the location very, very close to the end users. And they are talking about something like milliseconds of customers or just 100 miles of physical distances. So Gartner is a consulting company and publishing a lot of reports in technology trends. And this year he says distributed cloud or edge computing will be the top 10 technology trend. I believe that in the next decade, edge computing even become the mainstream. Okay, so all the big companies like Google, Microsoft, and including China, so Huawei, they are actually working on edge computing now. Okay, so I just mentioned the edge computing actually is something like you still have a central cloud, but most of the operation and data will be processed in this called edge servers or edge load, and very much closer to the end device or IoT devices. Okay, so that actually gives you a lot of advantages, like they actually save a lot of latency, right? You have very low latency, and reduce the data cost because you don't have to send large amount of data to the central cloud. Another one is that the data can be kept local. So for many of the privacy issues, privacy sensitive application, you don't have to send out the data. So for machine learning, you probably heard about this called federated learning. Federated learning means what? You train the data and then locally without sending the data out. So you just share the model rather than share the data, okay? And then edge computing, the major functionalities, for example, you have IoT applications here without just sending all the data or processing to the cloud or to your business data center, enterprise data center. You just actually rely on the edge servers or edge cluster, edge centers. And what actually can the edge center or edge computing do for you? Mostly, currently, they are still doing this, caching, transcoding, and that actually says that you don't have to always go back to the cloud to get your data, right? So you can have a local data management for caching, transcoding, and then you have a storage of your data. You can also offload your computation, because the end device of IoT device still very much limited in the capacity, resources. So the operations can be offloaded to the edge server. So you can do the processing here, and now more and more with AI, you can also have decision making, and also they can actually help you to do the stronger security because they can do the local encryptions rather than just rely on the cloud security solutions. So those actually are the functionalities of the edge computing you can actually rely on. And there I also mentioned some of the benefits, including that I said low latency and save your bandwidths, save the energy because the IoT device battery life can be enlarged, and also security and more privacy issues, and also you can have a more interoperability of your local devices, right, rather than rely on the central cloud, and everything should be new here. So you can see the major industries, including Huawei and Microsoft, Google, and Amazon, they are all pushing edge computing and extending their cloud services to the edge services. So in order to doing that, actually, the technology-wise still rely on the native kubernetes. Kubernetes is an open source system, actually automate the deployment, scale up, and also management of these container technologies. Containerized operation applications can be easily migrated, deployed to any of the devices. Okay, so the edge computing trend is still extend the cloud service models so that the end user probably don't even feel the differences. You still think use the cloud services, but actually you rely on a local edge service for your operations here. All right. And then how about the future edge computing then? That actually we'll say is entering the AIoT era. So IoT and AI in the past years actually developed separately, but recently more and more you can see they are actually merging towards each other because they can help each other. For example, AI can help IoT to do more intelligent operations, right? And on the other hand, IoT generates sort of data, and which will be used by the AI. AI now actually rely on a lot of big data. So they actually are transformation technology for helping each other. And this powerful convergence of AI and IoT will make IoT to do some more complex and intelligent operations. And AI actually will be embedded into every element of IoT. So you will see today when we talk about the IoT, we talk about smart sensing, smart networking, and smart things. I mean, the devices itself become very intelligent, and the smart computations and the data analytics and AI, machine learning, and finally smart control and also governance. So you can see with AI and all IoTs, all the elements of IoT will be becoming intelligent. Okay, and then what actually we can achieve by using edge computing for AIoT applications, then you can see that with big data analytics, actually the edge computing can have more data analytics to uncover the hidden patterns and the knowledge from this IoT big data. So by maybe 2025, 30% of the data will be generated by OT devices. Today, mostly still from web, right? From scientific engineering, but more and more the data will from the real-time collection of the sensors from IoTs, and also, as I said, more and more IoT operation will be proactive. So you actually do some preventive and or predictive operations rather than just see what happened in the past. That can save huge amount of money for the organizations. Think about a very expensive equipment, millions of US dollars. If you wait until it fail, then you try to repair. That actually can cost a lot of money, right? You have to stop your operation. You take the machine to repair. But if you can see predictively when this machine needed to be maintained, you can pre-plan, and you can actually do some scheduling of the operations. That actually is the part that you can save a lot of money there. So that's why I said the benefits, if you sell millions of dollars for maintenance in equipment, it can also provide richer user experiences because you can learn what the user's behavior and the patterns, and then you can actually best satisfy their needs. And also finally, you also have operational efficiency because you optimize the resources, you optimize the operations there. And the technologies actually, why future edge computing or AIoT can be the trend, because you can see in recent years we see a lot of enabling technology developments. That actually includes from the devices I just mentioned. So you have huge, larger scale connectivity of massive of devices. You do not talk about 100 or 1,000 devices. Talk about huge amount of devices can be connected, and the 5G actually now find applications probably mostly in IoT, not in our daily life. Okay, and with 5G, the huge amount of IoT data can be transmitted from small devices or to the small devices. Okay, and then sensoring and technologies. So a lot of material sciences development give us a lot of more smart sensors. Okay, including the wearable. Right? In Poly, we also have a new research institute called Smart Wearable Technologies, and for data, of course, we have cloud, and we have now it's called edge, and also big data analytics are there. And then we have this very powerful computing power is for the chips, right? GPUs, CPUs, and all these kind of technologies available for the edge devices, not only the central cloud. So I will talk about the edge AI. That means the AI moves to the edge computing rather than just seated in the central cloud. It's called edge AI. And the robotics actually will be the future main drive force for the IoT operation, because it can automate the operation for and with the human beings there. Okay. So with all the technologies there, and we will see edge computing actually push the intelligence from the central cloud to the distributed edge. So that's why we call it the distributed intelligence. Actually, the distributed intelligence will bring the intelligence closer to the network edge, so even embedded into the devices that can be accessible by the end users. Today, we rely on the AI models on the central cloud, right? Actually, we cannot we cannot access to the AI models. But in the future, AI models will be in your phone, it will be your refrigerator, it will be in your the healthcare devices, anywhere you can have. And further, as we will see, we will have a larger and a larger edge computing infrastructure, even from different operators, different vendors, and those heterogeneous edge devices can collaborate. Okay, it can be interconnected, and then we will see we will have this is so-called collaborative distributed intelligence. That means all the edge devices, they are not only standalone, providing service to the connected IoT devices, but they can also help each other to perform larger scale operations. And then we will see, actually we will see the three different kinds of direction for so-called collaborative distributed intelligence. One is called distributed collaborative task processing, and means if this edge device get data from local connected and perform tasks, but this edge devices also have the local data, but all the local data probably are used for a large scale industry operations, so they can cooperate to perform the tasks, right? So you can schedule the tasks from the local data operation to some of other edge loads, because it's high powerful, and or they probably need to use some other local data. So this is called collaborative task processing, task scheduling. Another one is called distributed machine learning. So you don't have to train and infer in the model like Dr. Hu said, all the machine learning in the central cloud. You actually can do the training. You can do the inferences locally by the edge devices. Okay. And I said that the advantages is that you can just use the local data without sending the data to the cloud, right? Privacy issue and the bandwidth issue. That's why local or distributed machine learning become very hard research topic today. Another one is autonomous, all right? Distributed autonomous operation. Before, when you talk of, for example, the multi-robots, and when you talk about the coordination is centrally done at a central server. But in the future, they will be fully autonomous. That means the intelligence will be located into individual vehicles or robots rather than, say, coordinated central by a central station or whatever. So in the past several years, we have been working in all the three different directions. So later part, I will introduce some of our research in PolyU. And mostly I actually have been the director for this called the Internet and Mobile Computing Lab. And this actually is established in 2004, so many, many years ago. We have been working starting from distributed internet computing and moves to wireless sensor networks, and then goes to the big data and machine learning. And today we will see we have mobile cloud and edge computing. And what we have been actually doing include this called smart sensing for complex object and human sensing. For safety issues, for example, they can be embedded into the smartphone or into the vehicles. And for engineering safety and structural health monitoring and intelligent transportation systems. For the healthcare, we actually have built a very smart wheelchair. It can actually recognize who's sitting there, and according to the posture, it can control the movement and also send out the warnings, etc. We use just the commercial Wi-Fi to detect human respirations and abnormal in the sleeping mode. Okay, thank you. And also recently we have been working a food safety project together with professor in applied biology department. So we developed a very low cost food safety monitoring device. This one like a liquid flow detection, and we just use acoustic technology. Usually acoustic technology devices are available in the market but very expensive, like thousands of US dollars. But we developed this one in hundreds of Hong Kong dollars. We actually use edge intelligence. We built the machine learning model on the edge devices. So that actually is endless device. This does not require connection to the central cloud, doesn't require any central server. So you can detect whether this wine is is a fraud one or it's a real one, a generous one. And another one is a very interesting one. We just use a camera to capture RGB image about the food, like bread and apple, and then actually we use the transfer learning to translate into the hyperspectral image, and then we'll be able to detect the freshness level about the food. And recently, actually, Queen Elizabeth Hospital feels this technology very useful for their patient skin perfusion. So they want to apply this one to check and detect the skin perfusion. So we are actually developing the project for this. And other things like edge computing for airport resource management, like the baggage reclaim belts. How can we know the number of packages that are there and from which airlines? And then combined with other big data, then we can actually have this is the baggage data and passengers mobility and data and the baggage takeaway data. Then we build this called a big arm AI engine, and that actually can help the airport to have very intelligent allocations of the packages on the claim belts. Actually, originally they just rely on the manual work, so they spend hours to generate the schedule every day. With our AI model, it's just seconds, and it's very much workload balanced about all the belts. And then we also developed this called edge device video surveillance. Remember before all the camera data need to be sent back to the cloud. Yeah, sorry. to the cloud, and then do the central modeling and then the recognition of the image of the object, etc. Now everything actually just done in the edge devices. We don't need to be connected to the central cloud server. That serves a lot of concern about privacy because the data are kept by yourself. It's never being sent out. And then we can, because I cannot show the demo here, and then you can actually have a collaborative video surveillance because multiple edge devices can be deployed, very conveniently cover large area. And also more recently, this has been applied to the hospital for the hand hygiene, monitoring the process, and very easily you can deploy it to the ICU to monitor the doctor and the nurses' actions. And last one, I will talk about the multi-robots for the autonomous cooperation. Autonomous cooperation means we don't rely on any central server, so it's fully controlled by the vehicles or the robots. And before, if you want to control a large group of multi-robots, you have to rely on a central server. Okay, other robots just collect the data, send the data back to central server do processing, send back the commands, right? But now they just fully operate just like a human beings cooperate with each other. And our solution, I think, is we actually is working for open space, so you don't need to deploy any of the tracking mechanisms. We do not need any of the localization system, and we don't need even the robot-to-robot communications. So purely by their sensing and then learning to work with each other. So we actually have been working for a single robot for the land checking. Now you can actually just draw some of the lands and then with different colors. That's it. So for example, in construction field, and it's very difficult to lay all the cables, etc. Right? So you can just draw some of the lands, and then the robot will recognize the different color, and then use reinforcement learning to just keep keep tracking in the land, and then they can actually walk along the track, and without actually any of the supervisions. And for multi-robots also, I have a demo, but I cannot show here, that they actually, when one robot actually try to bypass the land, and then they learn from each other, they learn the partner's intention, and also use reinforcement learning, and then they actually can successfully cooperate. And all of those, remember, is done by the robot itself, okay, the edge devices, without relying on a central cloud and central services. So you can see in the future, the edge computing can help us to realize this so-called distributed intelligence. Okay, so thank you very much. I think I will not cover this, and I remember just want to introduce our newly established called Research Institute for AIoT that heavily rely on the future edge computing technologies, and we work on the infrastructure and in construction, healthcare, connected vehicle, and logistics. So for all different kind of applications. Thank you very much.
Thank you, Professor Chow, for your sharing. Please remain on the stage. Thank you to all the speakers this morning for their insightful presentations. I would like to invite them once again on stage for a Q&A sections. Dr. Hu, Dr. Edward Zhong, Professor Chow, please. We are pleased to have Dr. Dennis Zhang, Program Manager of CARES, to be our moderator. Dr. Zhang, please. I'm now give the stage to Dr. Zhang.
Hello. Once again, thank you, Dr. Hu, Professor Zhong, and Professor Chow for delivering the interesting and remarkable topics to us. I'm sure it arouses our many interests from our guests, from our audience on the floor. So I would like to invite anyone on the, of our audience to have the questions. If you have any questions, please just raise up your hand, and our helpers in the room will pass you the microphone to you. Before asking your questions, may I also have your kind help for mentioning your name, maybe your organization where you're from, and who would like to direct your questions to one of our speakers. So I will give this time to see if there's any questions on the floor. So yes, please.
Hello, I'm Daniel Chan from Data Farm. Thanks for the wonderful talks this morning. I'm just wondering, now we have a number of problems in terms of safety and reliability, and we covered also a spectrum of solutions. So if I ask you, what would be the top 3 priorities for you in terms of solving these problems in the context of Hong Kong, or maybe in the context of a larger region, in our neighborhood? What would be your first 3 priorities in terms of, solving these problems?
So may I like to ask who would you like this? Who would you like to ask our speaker to?
All of them, if I could.
I think this question best answered by Professor Yung.
It come to me all at a sudden, right? So yeah, thank you for the questions. I think we have been running this center for quite a number of months. Actually, we started last year. Since then, we have been talking to many industrial leaders, including big enterprises and those manufacturing companies. So all in all, I think to kickstart on how to help people in elevating reliability and safety, first and foremost is that they really want to get started with their involvement. Now, a lot of times when we approach companies and enterprises, they come to us with problems, right? And then they have a mindset that, okay, I give you the problem, you solve it, right? So that may not be the best way to do, because our center runs in 2 legs. One is DDM, data-driven methodology, with all this data in the first place by sensing and by sensors. Now, even with data, we do need knowledge domain. For example, if we actually one of our collaborators is town gas, right? So we are academics, but we know not more than they know about town gas, right? So we need their expertise as well. So it's something like a partnership. Now, however, if we do not want to set aside manpower to collaborate, to dig into the problems, even though we have a lot of data, we do not have knowledge domain, and we cannot solve the problem in a very short run. So firstly, we have to really put resources into it, right? That's first. Secondly is data, right? Without data, we also cannot do anything. When we say data, a lot of time we may not digitize our data. Sometimes we have a lot of data, but handwritten data. So I think it's now the time to how to digitize our data. Okay. Now, of course, one of the drawbacks is I don't know what data is good, what data is not good. Don't worry about that. Start to build up a habit that we need data in the organization, in the process, in the product. So, but digitize them first. Okay. Now, with this digitization, then it's more easy to go forward the next step, right? Otherwise, we have to help the organization to digitize the data, which may take months, right? So that may be the second thing, right? I yet has to think about the third thing, right? At least these are the 2 things that I can think of right now, right? Thank you for the questions.
Okay, thank you, Professor Yung. So may I also invite if there's any other questions from the floor? Okay, so perhaps I have another. Oh yeah, okay, please.
I'm Tom Chan, Program Manager for CARES, who do data platform. And I have one question for Dr. Hu. So after 2014, after Ian Goodfellow created the generative adversarial network, it seems that there's always a theft or a thief and always a police in order to compete with each other. So my questions to you is about the data security. Given that there is countermeasures trying to fix you in the cyber world, in the AI network, what is the best known method, or what is the best strategy for you to counter or for you to protect your own AI knowledge? Just like what you show us, could be the face recognitions that is hacked or that is faked by some others. Think about that. In terms of security, you always use your face recognitions for you to log in your account. And sometimes you find that somebody else logged in your account and fake you out. So what are you going to do? And that's my questions. What is the best strategy, or what is the best known method for now in order to protect your own AI intellectual property right?
Okay, testing. Okay, thank you, Tom. Yeah, actually, it's a good question. So, first of all, well, maybe a little bit sidetracked. So, as you can say, ethical hackers or like a guy in the security field in academia, I think our role is a little bit controversial. So, we are sitting in between with the good guys and bad guys. Actually, the good guys, of course, we want to have AI systems. We want to enrich our life and increase our productivities or increase our reliability and safety. But always there are bad guys. They are actually hackers. They are ethical or not ethical hackers. They are probably, they want to gain profit from the system. That always be this kind of thing. Just go beyond the AI era, right? We still have hackers. So we as the academic professors in this field, we try to do something in between. Actually, let's say when AI is not that popular, maybe 20 years ago, actually we are already doing something like that. But on that time, we are just doing it on behalf of our the bad guys, because at that time there's no profit in actually hacking an AI system. But the safety issue, the reliability issue of the AI system is still there. So we need to fill in the niche. So we need to study on it. But right now, actually, we see the trend of how AI systems has been applied to daily life, to business. So right now, there are plenty of hacking efforts, not from us, but actually from the professional hackers. They are doing that. Okay, so we now somehow switch our role, start to do the defense schemes. We try to see what kind of real vulnerabilities these system can have, and then try to. Unfortunately, I don't have enough time on today's talk to talk about defense schemes, but actually this is our focus. And to echo your question on right now, what can we do, right, to protect our face from maybe face or other asset in our AI system? Actually, well, this is kind of an ongoing battle between us and the ethical hackers. Actually, what we can do is trying to follow the suggestions. As I said, right now we have some remedies. Of course, it's not perfect. Right? For example, like whenever you try to upload your photo, right, in Facebook or Instagram, you can try the tools that our academia has been developed, so that actually other face recognition system cannot utilize these photos for their own purpose, right, to build their own face recognition database. And also, as I said, if you are developing an AI system and then you are afraid of being attacked by adversarial samples, I have already told you that actually we have a very simple technique called adversarial training. Actually, you can train up your AI system to guard against these AI adversarial samples. Of course, it's not perfect solution, as I said, but this is what we have right now. Okay, thank you.
Okay. Thank you, Dr. Hu. May I introduce, may I ask if there's any more questions from the floor? Perhaps I will have a question to Professor Zhong. After Professor Chow's interesting topic on AIoT, so I was wondering if AIoT is also a trend for smart transportation or smart traffic management.
Yeah, I think that's an interesting question. That's something I'd really like to talk to Professor Chow as well about this collaborative intelligence or distributed intelligence. I think at this moment, the way to control is from the center, and you send the instruction out. I can imagine that in the autonomous world, that I don't believe that the autonomous vehicles will just drive by themselves, because you still need to have a higher level optimization, from the network perspective. So yes, the vehicle can drive by themselves, but is it optimal from the network sense, right? So that decision still need to be made. But nevertheless, I think that some of the intelligence can be built by section. So let's say you have a large freeway. So certain sections, the data collected for that sections, collectively, some intelligence can be built so that the decision can be made at that level. You don't have to make a decision for the whole network, but at that section that can be made. So I think there is I'll be very interested to talk to Professor Chow about that.
Okay, thank you, Professor Chung. And perhaps I may also have a follow-up question to Professor Chow as well. Apart from smart transportation or traffic management, what do you see the AIoT in the next 5 or 10 years? What would be the hottest topics or hottest applications for AIoT?
Actually, I mentioned in our new research institutes, I think AIoT and edge computing in Hong Kong. So we focus on smart infrastructure including like buildings, bridges, like the Hong Kong government now to develop this Dayu, the new city there. So they actually try to build from very beginning, the ground to the applications. So the technologies like digital twins, right, needs a lot of edge computing and AIoT. And another focus area is personalized healthcare. I mean, we all go to the hospitals, but later on we actually rely on ourselves to monitor our health at home, right? And then for many of this decision and the smart diagnosis, etc., they actually can be done by the edge device. Actually, now everyone wears this wrist wear. They are also monitor your behavior and build the machine learning model to actually give you advices, all the things, right? So healthcare also works for elderly care. Elderly care, I mean, for elderly people, they cannot take care of themselves. The AI model will be very, very useful for them. And the third one is the transportation. Connected vehicles, like autonomous driving, need a lot of edge intelligence as well. I think, as the professor mentioned, that you need some of the global information network-wise, and then the decision making probably should be pushed as much as possible to the edge, because the real time, the instant reaction, all this actually require very low latency, right, and very immediate actions. So that also need edge computing and with AI. And the last one is logistics. So we are talking about logistics, and logistics actually covers the processes, but in terms of the particular location, particular operations, and the edge also can provide some the in-time support for this.
Okay, thank you.
I'd like to add on that. Actually, AIoT is the way to go, right? And actually, it would contribute a lot to the next 5 or 10 years, particularly under the government promotion of smart city, right? Under smart city blueprint, if you go to the government website, they have a few pillars like smart manufacturing, smart maintenance, smart transportation, smart building, and smart utilities. And actually, CARES is doing all our projects under these 5 umbrellas. In fact, in the afternoon, there will be 3 renowned speakers from the industries telling us how they apply more or less AIoT in their different industries. All right. So all in all, that's the way to go, right? AIoT.
Okay, thank you, Professor Chow and Professor Yong. And actually, time flies. I think it's about time for our lab tour or lunch. So I will pass back the time to Jen, our MC today.
Thank you, Dr. Zhang, and all our speakers. Please be seated. Okay. Thank you, all guests. This brings us to the end of the morning sections. I hope all of you enjoyed the presentations and discussion this morning. It's time to have a lunch break. Afternoon sections will start at 2 p.m. Looking forward to seeing again before 2 p.m. here for the start of our interesting talk this afternoon. Those who registered the lab tour at noon, please wait at receptions area. Last but not least, don't forget to get your CPD certificate for the morning sections at the receptions. Thank you. See you in the afternoon sections.
其實我哋 care 啦，咁我哋 initially 其實係理工大學同埋一間美國嘅大學 University of Maryland 啦。咁其實我哋係主要做啲 reliability and safety 嘅 research 咯。咁我哋主要應用我哋嘅research 其實喺唔同嘅都可以。咁如果大家有興趣嘅，咁就都可以 follow 我哋一啲 media 啦。咁譬如有今日嗰啲 event， 我哋都會即時會知道。咁大家都可以嚟睇呢個，因為無論喺香港定其他地方，其實 reliability 咧係重要，係因為即係無論每個系統同埋機器咧，裏邊都會有啲老化，軟件會有故障啦，同埋好多唔同嘅其他因素嘅，好似係一啲環境因素啊，或者一啲係人為嘅因素點樣去用個系統都會影響到。咁呢個其實係簡單介紹翻俾大家睇reliability 同 safety。如果我哋做 research 嘅話，嗰個概念或者 approach 係點咧？其實我哋好着重就係用個 AI 嘅 approach 嗰個系統裏邊剩餘嗰個壽命，因為講緊係 reliability 嘅。咁另外一樣咧就係講緊我哋會有兩個 approach 啦，我哋喺邊度 approach。咁 data driven 啦，即係我哋會用啲 data 嘅 approach 去研究嗰樣嘢。另外一個就係 physical 嘅。咁呢度係大概講一講我哋其實 centre 裏邊咧有5個 program 嘅，咁 total 裏邊有15個 project 嘅。咁 anomaly detection 啦，佢哋 data analysis 呢樣嘅。咁我哋主要做啲 predictive 嘅 reliability。咁呢啲係我哋陣間大家就會去嗰個 lab 去睇一睇。其實係一個 remote access 啦。咁我哋就其實我哋最嗰個出發點就係 NVIDIA 嘅 DGXA 100就係呢度啦。咁呢度其實 show 一個 screen 咧，其實想話俾大家聽，其實佢裏邊咧有8粒嘅 GPU 嘅，咁佢可以同步咁去 run 嗰個唔同 program 啦。因為我哋 centre 裏邊咧，其實有唔同嘅 project 喺度 run 嘅，有一啲 reliability 嘅 model 嚟嘅工作。咁其實我哋都可以同啲 collaborator 即時攞一啲數據，咁去做喺度個 supercomputer 做一啲 model。
佢裏邊都有一個 function 叫 NVLink 啦，其實就可以同步去温嗰啲 GPU，咁就令到嗰個速度更加快。因為通常做一啲 machine learning 嘅 model 咧，都會係一啲好大量嘅 data，咁可能去到 TB 啊以上，所以就會比較使用呢啲 super computer。咁呢度其實我哋會攞到一啲數據，佢係一個 time series 嘅 data。咁其實呢個係一個 sensor 嘅 data， 你可以想像係一個震動或者係擠壓嘅數據。咁攞咗呢個數據，其實佢可能係好大量嘅一啲數據。咁我哋就會做一啲 transformation 啦，同埋一啲唔同嘅 machine learning 嘅方法。譬如呢個圖咧，你會見到佢 keep 住轉啦。其實佢呢度有一個 terms 咧，其實係講緊唔同 machine learning 嘅方法嚟嘅。咁佢唔同嘅 machine learning 咧，就會做咗唔同嘅 distribution。而呢個 distribution 咧，其實之後咧就因為我哋 centre 有一啲 AI 或者 machine learning 嘅 expert 喺度啦，咁我哋就會透過呢啲 analysis 去揾翻一啲 outlier 或者一啲 anomaly 出嚟。咁其實目的咧就係想揾喺一啲大數據裏邊揾到一啲有 value 嘅 data， 點樣去揾一啲anomaly 出嚟，或者提前去有啲警覺俾嗰個系統嗰個使用者咁樣。咁呢個係大概我哋講緊話點樣應用 super computer 去一個 AI 同埋一個 reliability 嘅analysis 上面，即係大家有一個印象喺度。咁咧接住落嚟咧，呢度咧其實係一個session 咧，就大家可以一齊玩下嘅。咁其實呢個咧就係講緊一個可以大家 interactive 啲，可以諗下 reliability 喺個smart city 裏邊係有啲咩嘅重要性咧？咁大家可以去睇一睇我哋後裏邊咧有唔同嘅橙色 label 啦，譬如同事可以 scan 一個啦，譬如 smart surveillance 咁啦。咁 smart surveillance 喺 reliability 係好重要嘅，點解咧？因為 smart surveillance 咧佢會牽涉到一啲 CCTV 啦，大家會諗下，如果個 CCTV 係蒙咗嘅，或者佢睇唔到嘢嘅，其實佢個後果就喺個 city 裏邊就好嚴重，因為佢關乎啲安全性嘅問題啦，就可以譬如啲信落去啊，或者嗰啲 smart building 裏邊都會成日用到嚟㗎。
檢測，呢個未定型㗎，跳緊㗎。我呢個唔喺嗰個比例咧，咩唔同咧？
都包括第一個就係一個電機嘅預測維修啦。咁 Predictive Maintenance 其實我哋嘅主題嚟嘅。咁啊，譬如我哋而家喺個發電廠啦，煤嘅發電廠上邊啦，咁啊有個隨流裝置嘅，即係煤會產生一啲硫嘅有害嘅氣體啦。咁個隨流裝置其實係一個好緊要嘅 machinery， 咁啊對 safety 好有關鍵作用嘅。咁我哋就用一個 FMEA 嘅方法啦，咁睇翻佢個唔同嘅問題啦，同埋做翻個 effective analysis 啦。咁我哋通過啲傳感器，我哋會 detect 翻嗰個隨流裝置嗰個摩打啦。咁好啦，跟住落嚟就關於一個飛機嘅拖頭啦。咁飛機拖頭當然啦，喺個機場上面大家都會見到啦。咁呢啲飛機拖頭其實如果有問題嘅話，其實會好影響飛機嘅升降啦。一處嘅 formation 咧，就會影響到供電，最後會 break down 嗰個 cable 嘅。咁我哋做嘅方法咧，就係我哋要 identify 呢個問題咧，跟住先至可以睇到啲 anomaly 出現咗，我哋就會進行一啲跟住去做啲 replacement 啊，或者進行啲維修嘅。咁呢啲都係我哋做緊嘅項目啦。最後就係鐵路啦。咁鐵路亦都係同 safety 好有關係啦，包括佢嘅路軌啦、轆啦，同埋佢嗰啲轆同埋路軌都好多會有，譬如間唔中會有啲變形，因為經常使用啊嘛，會有變形啦。將個 sensor 我哋睇翻佢成個 sensor 嗰個 aging curve， 而從而 predict 翻佢嗰個 sensor 個 sensitivity 會唔會有變化。咁好啦 ，Power Electronics 上邊啦，咁啊 Power Electronics 上邊咧，我哋一陣間都會睇到一部，我哋應該有一部全功率啊手位一指嘅儀器，我哋可以度到一啲Power Electronics 嗰方面啦，特別係 MOSFET 啊、IGBT 啊嗰啲嘅。
大家俾個 number 翻我好唔好？係啊，好。係1、2、3 ，OK， 搞掂。
當頭先我哋嘅 mainly 有3個 area of category of equipment 嘅。第一個就係 temperature and environmental testing 啦，都好多人用嘅呢個。 就第二樣咧就係 life cycle assessment。而家呢個 area 咧，我哋叫做 battery life cycle assessment。所以而家咧，我哋入邊係有個 alkaline battery 嘅。所以咧，我哋入邊嗰個 battery 咧就 connect 到一個用 fiber optics 叫做 FPG sensor。我哋可以咧就睇下個溫度同埋個 pressure of 嗰個 battery。所以你哋如果有興趣都可以睇下我哋嘅 setup 啦，或者呢個係一個 experimental setup， 你可以睇下我哋放個 alkaline battery 啦，響出邊同埋入邊。所以因為我哋好多人知道出邊好容易 measure， 入邊嘅 battery 點樣 measure 咧，佢就用呢個 fiber。
咩嚟㗎？中間嗰個。
中呢個合一啲，入邊咧就比較。
我入邊係個 cell。
Distinguished guests, ladies and gentlemen, good afternoon. Welcome to Artificial Intelligence Transforming Products and Impacting Safety and Reliabilities, organized by CARES. I hope all of you enjoy your lunch, and now it's time to start the afternoon sections. Before we start this afternoon sections, may I prompt the audience that there will be a Q&A sections at the end of this afternoon presentations. If you have any questions that would like to ask or discuss with our speakers, please drop it down and raise your hands at Q&A sections. To begin the afternoon sections, I would like to invite Dr. C.H. Ng, Chairman of the Hong Kong Electronic Industry Association, to give us opening remarks. Ladies and gentlemen, let's give a big hand to Dr. Ng.
Professor Yung, distinguished guests, ladies and gentlemen, good afternoon. It is a great pleasure and honor for me to be here on the occasion of the opening of the official opening of the CARES Technical Seminar, Artificial Intelligence, Transforming Products and Impacting Safety and Reliability. I would like to express my sincere thanks to the organizer for inviting me to deliver a few remarks on this occasion. First, let me provide some background in relationship between the Hong Kong Electronic Industry Association, Hong Kong EIA, and CARES. With the mission to promote electronic industry in Hong Kong, for years, Hong Kong EIA have submitted proposals to the Innovation and Technology Bureau for the improvement of the industry. In 2019, when we saw the need to improve product reliability and system safety for the industry, we have submitted a proposal to support PolyU to launch a project in this area. Subsequently, the Center for Advances in Reliability and Safety, CARES, was established. As AI would be widely applied, we have also donated a leading AI supercomputer to the Faculty of Engineering of the PolyU to support the research by PolyU, as well as to bridge the gap between business and research by providing training to PolyU students and Hong Kong EIA members. Electronic industry in Hong Kong is the territory's largest merchandise export sector, accounting for 71.8% of total exports in year 2020. According to the Census and Statistics Department and the Hong Kong Trade Development Council, the value of total export of electronic products is over 2.8 trillion Hong Kong dollars in year 2020. Product reliability and system safety are fundamentally related and important to all electronic products, as well as to our daily life. Hong Kong EIA has fully support the activities of CARES. Today's seminar covers a wide range of professional subjects related to product reliability and system safety by using AI solutions. Our distinguished speakers include Mr. Jeff Tang from ASM Pacific Technology Limited, Mr. Harry Sun from Respect Intelligence Inspection Limited, and Dr. Charles Zhang from NVIDIA AI Technology Center. Please join me to welcome them. Finally, wish you all enjoy a fruitful and successful seminar. Thank you.
Thank you, Dr. Ng. Please remain on the stage for presenting certificates of appreciations to our speaker in the afternoon sections. I also wish invite Professor Winkle Yong, Center Directors of CARES, to come on the stage with Dr. Ng for presenting certificates of appreciations. In these sections, we are honored to have 3 speakers. As a token of gratitude, we will have a certificate of appreciations to them. The first one is Mr. Tang Chi Wai, Jeff, R&D Manager, ASM Pacific Technology Limited. Mr. Tang, yes, please come to the stage. Thank you, Mr. Tang. Please wait at the side of the stage. The next is Dr. Charles Zhang, Senior Data Scientist and Deputy Director, NVIDIA AI Technology Center, Hong Kong. Okay, thank you, Dr. Zhang. Could Dr. Ng, Professor Yong, and Dr. Zhang kindly remain on the stage for the photo with Mr. Tang? Yeah. Thank you, all the guests. Please be seated. Mr. Tang, please remain on the stage. The first speaker of this section is Mr. Tang Chi Wai, Jeff, R&D Manager, ASM Pacific Technology Limited. The topic of Mr. Tang's presentations is reliability with predictive maintenance. Please welcome Mr. Tang.
Thank you for all to join this seminars, and it is my honor to be here, be invited as well. So today my topic is about how to use deploying the predictive maintenance to improve electronic modules and machines, equipment reliability, and also how ASM Industrial 4.0 solutions will help to enhance our customer and product reliability as well. Okay. So let's refresh what is benefit gained by from the predictive maintenance. So in the past, let's say imagine you are manufacturers like Foxconn. You have a number of machines on your production floor, and those machines will suffer from aging. Say the bearing itself will wear out, the timing belt will wearing, and the product made by these aged machines will have caused the product quality degraded as well. So even the machine itself will have a breakdown. So after the breakdown, you have to call the service. It will spend maybe a day or a few days or even months to have the machines repairing and resume the production. So it is a kind of losing productivity of your plant. So a better way is to using a preventive maintenance. You have to regularly replace some wear part, doing some lubricants to prevent the machine breakdown or affect your product qualities. But with this concept, where you will spend maybe once a year or twice a year to have the machine stopping for the maintenance, so it caused the operation cost increased. And also, actually the machine itself is not breakdown yet; it's still functioning, produce good products for you. So why we would like to have a predictive maintenance? Since if we have monitoring the conditions of our machines, then we can predict when will the quality of the product will be out of specifications, or even the machine will break down, so that we can call for maintenance right before occur of reliability issues. So we prolong the machine's availabilities so that we can increase reduce the cost of ownerships. So this is why we would like to have a predictive maintenance. So ASM, we providing a number of different kinds of machines for semiconductor solutions. In these sectors, we have a machine start from a wafer sawing, isolations, and die bonding machines. We have wire bonding machines connecting the wire from the IC, the die, to the lead frame that have a number of output wires, so that at the end we have encapsulation machines and trim form of the output pins, so that you can see the integrated circuit selling in the market. And beside the semiconductor solution sectors, we also have SMT solution sectors. Focus on the electronic printed circuit board assemblies. We have solder plate printing machines, and also the top-end pick and paste machines, high-speed tip machines. So today, I will focus on one of our series, wire bonding machines, which we deploying the deep learning neural network to achieving the predictive maintenance. So what is wire bonding? Shown over here, this square is a portion of the die, and the lead frame underneath the output pin. So we having metal connectors, which could be aluminum wire, a gold wire bond, also copper wires. Up to now is the latest, because copper provides the lowest resistor, and it will reduce the power consumptions of the integrated circuit. So first of all, inside our wire bonding machines, we have to identify a number of modules inside our machines where it will have aging issues, or the degrade of those components will increase to cause the product made by our machines will have reliability issues. So we link down a number of modules inside with the mechanical moving part, the XY table, which moving the wire needles around, and the bond head together. And in this also is fitting the lead frame together with the die on it. This kind of mechanical parts will suffer from the agings of the mechanical LM guide, linear motion guide, bearing itself. Yeah. And the transducers, which producing the ultrasound vibrations, so that is crucial for the wire bonding. We will weld the copper wires or gold wire together with the die surface. And YCAM, we control the fitting of the wires. And this one is spark generations. spark generator that used for the before we welding the wire, we have to burn the wire to form a circular ball for the bonding. And also the nozzles. This one is produce a controlled environment to prevent the copper wire from oxidations. So those components is very crucial for the quality of the wire bonding. Yeah. Any degrade of those parts will affect the end product, the wire bonding qualities. And for those modules, we have to monitor number of electrical properties, the input voltage, command current, and the actual current flowing through to the modules, and also the powers. So to monitor those informations, we have to develop another separated hardware to collect those data. Why? Because we don't want to consuming the power, calculation power, the computation power of the machine itself. It will degrade our performance, machine performance. So we have to develop a separated hardware for the data collections. And then all the data will send to the AI server, back-end AI servers. And then from the server, web access, the server can collect those conditions of the modules, and you can see have different warning. And we can predict the remaining useful life, predict when will the quality of the wire bonding will be out of our expectations. Yeah, this is the whole overview of our concept. So actually, in the AI servers, the core of our artificial intelligence is using the deep neural network. Engineer inspired from our human brain. We are using the neural in layer by layers. We have input layers. We have hidden layers in between, and have output layers. So they call deep neural network. So we have to train this network with data first. So we collected 50 machines data from the manufacturing, and then collect those parameters I just taught to you before. And then we make sure they're doing the same wire bonding on the same products, and then we make sure all the bonding quality is good. So we train the data with those good data to the network, and then we have comes out the health index, we call it. So this index will tell how good of the electrical parameters. So what's mean by good wire bondings? Usually we have to measure the bond size, the ball size of the die surface and also the lithium surface. And we measure the loop height. We measure the pulling force, bonding force on the ball side and the tail side. Yeah. We use those parameters to setting the passing criteria. So this kind of a train neural network, we using all the good data for the training. We call it semi-supervised deep learning method. Okay. So after the training, we have to define the failure criteria, failure line. So we artificially inject some infect the quality of the parameters so that we can keep track, see the trend of the health index. Some trend is moving linear, some will moving exponentially. So with the auto regression method, so that we can, from a certain part of the data, we can project whether it will hit the fail line or not. Fail, that means the wire bonding quality is out of our expectations. So actually, for the wire bonding data, it looked like normal distributions. So imagine that for good data, it will look like a distribution, and then during the aging, this pitch will be moved, maybe left or right, and out of the boundary until it hit the red line, the failure line. Yeah. These are our concepts. So I just talk about how we train the network and how we define the passing rate, the failure line, and how to predict the remaining useful life. So in here, I would like to share you 2 cases to how to verify the quality of this trained network. So this is the first case. So for the wire bonding, this copula, the trick is look like a harrow shape. The metal wire is fit through at the center hole, and at the tips we have doing the spark ball burning, and then for the wire bonding, with this capillary we have a screw bounded to the metal horn, and at the end is the transducers which produce the ultrasound vibrations. And this vibration will through the horn and then up to the tips of the capillaries. So the network tell us if we monitoring the transducer RMS powers, so we can, from this information, we can tell the health index will be changed according to the tightening of this mounting screw. And this is very crucial for the wire bonding qualities. So you can see by releasing the screw, then we can find how the trend is look like linear. And then we tighten the screw, and then we do it again. You can see linear relationships. Okay. So this is the first case. This is a second case. Also the capillary. Actually, the tips of the capillary look like a very sharp little head. And after certain bonding cycles, then the tips will be wear, and the bonding quality also affected. Yeah. So the level tells us if we monitoring the health index for the transducer voltage, then we can tell whether it's related to the tip wear information. So I show here 2 waveforms. One is the good capillaries, and one is the wear dead capillaries. So actually, by human eye, human brain, we cannot tell it's already weared. But for the network, the neural network, it can tell. So it's the benefit, the good way from the neural network. Besides the aging issues, the neural network can tell from the health index. We also can identify some common issues by the neural network, such as losing any encoded signal, cable broken issues. Those common issues from the field also can be identified from the neural network. So these are the AI servers, the web access to the AI servers. You can see these machines under monitoring, and green light means that module is under the good conditions. And it should be a yellow, right? Yellow is, that means it's already out of spec, but it's still producing good wire bonding qualities. But for the red, it's almost close to the end of the useful life. So it leads to arranging repairing, maintenance, actually. So up to now, up to now, we have covered how ASM wire bonder machines make use the deep neural network to achieving predictive maintenance. And this method can reduce the unplanned failures, so that increase our machines availability, increase the reliabilities. Yeah. The rest of my presentations will focus on how ASM Industrial 4.0 solutions will help our customer to increase their end product reliabilities. Okay, back to the neural network, the trained network. Actually, the network itself is doing a good job to identify any poor quality of the wire bondings. So from these examples, we can from this index, it can tell the Y clamp current have abnormal. So it may have issues on the Y bonding already. So how important of an individual wire impacting to the customer qualities? So shown in here is examples. Let's say in the electric car, if the IC, the integrated circuit, have one failure per 1 million part, then a number of integrated circuit put on the PCB board and number of board integrated to the electronic control unit and number of units put in the car, then 1 ppm is already caused about 1% failure on the electric car already. So it may cause to total recall of the products. So it costs a lot of money. So this is why heavy wire bonding is very crucial to the end user's qualities. So these are solutions from ASM. We expand the concept we implemented in the wire bonding. We have the funder monitoring all the data, and then expanded to other products altogether, and then have all the data sent back to the back end. We call it SkyEye AI servers. So with this concept, there's a number of functions can be provided. So the first is connectivities and controls. Since a number of machines are connected into the back-end server hub, we can, through this hub, to connect the users or our service guy, ASM, can remotely control the monitoring the conditions of each machines individually. We can doing some parameter changes, set up thing. So this even doing some remote diagnostic to check the health of the individual machines. And the second function is if we having a more quality monitoring device, AOI, that means optical inspection machines, then the bonding quality can be told from this unit. So we can tell the overall equipment effectiveness to the customer to monitor the productivity of their plant. This figure is including 3 main key KPI. One is the machine availability. That means is there any failure, breakdown, or material shortage? It caused the availability of the machines reduced. And the second index is about the performance. That means it compares the speed of the machines to the ideal cases so that we can see whether the machine is run in the optimum performance. And the last is the quality. With the AOI, the optical inspection machines, we can tell the quality of the wire bonding. This is the third functions provided is including the artificial intelligence in here. So beside the AOI, we can add another online testing machines, auto gauge that can test the bonding force of the wire bonding, and autoscope is a 3D inspection machines. It can tell the other more information, all-round information beside the AOI optical inspections. So with this integrated together, we can correlations the bonding quality with the bonding parameters, so that we can fine-tune optimum the control parameters, so that we have the best bonding quality, so that increase the end customer product reliability. So I think almost the end, this is my last slide about the whole concept of Industrial 4.0 ASM visions. So I already talked about the bottom 2 layers, about the machine itself, the diagnostic itself, And the second area is about the sky eye. We can monitoring the overall equipment effectiveness and also the correlation between the bonding parameters and the quality of the wire bonding. And then this is under the shop floor level. If our plant have a number of 4, then we can integrate together to have a 4 levels. And with this, we can have a manufacturing execution system. So actually, it controls the material planning, any maintenance events can be controlled over these layers. And the last layer is about the cloud. So it can all the information put in the cloud so that if you have a factory in China, in Taiwan, in Singapore, then you can have all the information on the cloud. All the information can be on your fingertips. Yeah, this is our ASM Industrial 4.0 visions. So I would like to say this project is still under development. It will be a long journey developing with our customers. Yeah, hope it will be. We can see this product in a couple of years. Yeah. Thank you. This is the end of my presentation.
Thank you, Mr. Tan. Thanks for your sharing. Please be seated. Our next speaker is Mr. Harrison, CEO and founder, Respect Intelligence Inspections Limited. The topic of Mr. Sun's presentation today is AI-powered solutions for improving building safety. Mr. Sun, please.
Good afternoon, ladies and gentlemen. I'm Harris. I'm the founder and CEO of Respect. First of all, thanks very much for Professor Yong and CARES for having me in the seminar today. Respect, we actually founded 3 years, so now it's around 3.5 years. We are one of the incubators in Science Park. So what do? We actually working out the AI technology for safety and reliability for smart city. That's why we have a strong synergy with CARES, right? Thanks for that. We also found it's very important because quite a number of like startups or like even when we talk about like AI technology, so many of us are like very focused on features, right? What kind of features we can provide to you, functionality we can provide to you, but safety and reliability is a very important piece that every one of us have to keep in mind. So that's why Respect and CARES hope to like kind of make it, viral and make it review. We reinvent the wheel of the industry, right? Yeah. So what we have been doing is like is actually a big picture. We start with small. We start in a smart building perspective. Can I take the mic out? Yeah. So we start in the smart building perspective. A couple of years before, we work in the facade by using drone. Just give you a little bit background about myself. I graduated from computer science and engineering, and then I work in like a long journey in startup industry. Actually, I've been in Beijing for working on social media before Facebook was actually very famous. It was in 2006, something like that. And then after that, I've been to in Cathay. They would like to in 2012. They would like to found the Innovation Center. Then I was the first, staff to set up. I was the founding member of the Innovation Center of Cathay Pacific Airways, and I'm taking care of the business units for Swire, Cathay Group, etc., etc. And like worked out quite a lot of system and technology for the SWI and Cathay. And one of the keynote projects that we worked out is to use the drone technology with AI. We pair with like our in-house team and also with Microsoft and Intel to work out a drone inspection for aircraft, right? So that's why after that I found a company with drone and inspect the facade. You know, everybody say Hong Kong is a small market, right? Nobody will disagree. But one important piece in Hong Kong is the major market. Do you know what it is? Yes, building and skyscraper. There are around 5,000 skyscrapers in the world, which what we are talking about is 150 meter tall. And 1/10 of the building skyscraper is in Hong Kong. So we are actually the major market in the globe. So what we are working out the solution is on safety and reliability for skyscraper firsthand. And what you are talking about is not just facade, but also about the E&M stuff like the elevator, chillers, electricity, water pumps, etc., etc. So we, one of the keynote successful cases, we implemented technology for ICC. So we like kind of inspecting, we're still inspecting, routinely helping them to inspect. And also we deploy the technology for elevator monitoring. And we work very closely with Schindler. And also for E&M stuff, we've worked with Mitsubishi and you know, a couple of partners that we rolled out the technology together. The problem is very trivial because the whole chain of business in inspection and monitoring is actually labor-intensive exercise. So pretty much it's like very high cost, risky level, because if you imagine like people or workers have to come out to like on gondola in ICC, right? Very risky. Regulation difficulties, because like from government point of view, how I can, just recently in Saturday, right? The government also have issues reporting about EMSD elevator monitoring. It's not enough and insufficient. No, that's kind of it, because it's purely because of the labor-intensive effort. So how we can, by means of like robotics, IoTs, and also AI, to change the paradigm, make a paradigm shift for the industry. Costly and also inconsistency of professionals. So Respect, we are providing this kind of like full suite of AI building inspection technology. We call it Respect ACE, which is the AI cloud engine. From that perspective, we integrate with like underneath BMS, which is the existing technology in the existing building infrastructure, IoT integration, BIM, whatsoever, digital twin. And we are very concentrate on this 4 aspects. So what we are talking about is like AI-powered visual analysis. We use visual because most of the time when we do inspecting, people or engineers use bare eye inspection firsthand, bare eye inspection, and bare ear inspection, which is about vibration, where we come into, we monitor the bearing. So every motor or bearing needs inspection or monitoring by means of vibration. So that's why we have a very strong piece and R&D on vibration monitoring. The other one is about infrared. Infrared is very widely adoptable in E&M. Like we try to inspect whether those components are overheat. On external surface, external walls, which we help monitor the leakage, the water leakage, or the air leakage on the facade. So by means of the infrared. And the last but not least, which is the magnetic monitoring. We use this technology to monitor the roof. So imagine for roof monitoring, for example, in elevator, right? So the lift engineer, they have to stop the lift and to close inspection by using bare eye and just inspect on the surface. Bare eye, just surface, and they have to stop the lift. Right now, by using the Respect technology, we can deploy the magnetic AI that we can use it 24/7. and then inner wire. So it's not just surface, because we use magnetic flux, the change of magnetic flux, to identify the defects that are happening on the wires inside, like some abrasion or failure or fatigue of those wires, broken wires can easily be identified. And we can identify the severity, the location very exact. So no more inconsistency of experience, right? So, and altogether, we provide the hero products, which is like the facade, the elevator, as well as the chillers. As mentioned, we have deployed quite a couple of buildings in Hong Kong. The major hero product is on facade. So like quite a number of listed companies that have been using our service. One of them is like the ICC. That is the digital twin that we provide to ICC. This, as mentioned, why we call digital twin is actually the twin of physical and digital world. So whenever you look at the digital model, you are actually closely monitoring on the physical world, right? So we can type into any one of the elevator and give you all the metrics in real time. And we give you all the alerts. It's not just threshold alerts. We are actually examining the components. What are the root cause of failures? What exactly happening? Why it deviates? We give you the root cause. That's why we pretty much work out very deep tech and R&D on the understanding of the components, because we are not just providing an IT perspective, digital transformation of that piece. We are actually a team of domain expertise in this area, so that we understand the data itself and what is the sequence or effects of those data. And that's why we flip you all those matrix, which is like what's happening, what stage are they at. It's just like diagnosing a cancer patient. Oh, it is in stage 3. You have to be very aware. Is it in stage 4? You better have to repair it. Otherwise, it will stop disruptively. We give you that kind of signal, alert. The other one is, this is like just an onion peeling layer by layer. We can examine the component itself. So you can see the motor over there, right? The fan is actually running because it's a digital twin. So it's not a snapshot. It's not a snapshot. Give you all the metrics and alerts that the brain that the Respect Ace provided, and to flip you what's happening in the real world. So you can just sit over in your office and understand all the thousands and thousands of properties outside. And it give you a very comprehensive understanding of what's happening. We called it Respect Ace, which is the platform that we built to serve our customers. So we can leverage on this platform to save more than like 50% of operation time and monetary cost, and reduce the downtime as mentioned, and also the overall data management condition, and also the lifetime, extend the lifetime. Because previously people are using or adopting the preventive maintenance, we change it or repair it or regularly on a regular basis instead of like extend the lifespan of the components. But right now, because we have that technology working in real time so that we understand what is the condition of those components. The workflow, it doesn't matter whether it's in external wall or in indoor E&M thing, is also, we patent that technology, which is like undergoing the autonomous data collection or data harvesting. So by means of like the robotics, IoT, so we collect data in a very precise way with location and with a timely fraction. We understand, we work out a couple of like series of pre-processing or post-processing, that is a cleanup, cleansing, segmentation, localization of those data before it comes into the AI engine. So here we analyze, like if we is on the root perspective, we analyze by using visual and magnetic on the roof, as mentioned. And also if it's on facade perspective, we understand like what are the building components or those defects classification that and the severity of those happening on the external wall. You can see different colors, right? They represent different components, and also the bounding box in AI terminology we call bounding box. It actually helps you to understand what is the classification of that defect and what is the severity of that defect. And then we provide the cloud platform all in one go. So you have the graph visualization, digital twin that I just presented for you to understand the real-time condition of the buildings. And last but not least, of course, we give you the predictive. So it's not just reactive. Now it's very reactive. Not until the accident happening, not until you get locked in the elevator, you're not going to call the management office. But can we have a better story of that? Can we do something more predictive before the lift locks you down? Can we tell the customer or the passenger, hey, don't go to the lift because it's about some out of service? So we can do it. So the whole platform is like GIS empowered, PIM integrated, automated data processing, etc., etc. So that is to enable the platform, which is on one side is to integrate with the existing building system. The other hand is to enable the AI such that it's no longer manual or very labor-intensive way of working out the operation. So the main idea is to improve the operation efficiency, the safety, and reliability. So this to give you the full picture of what's happening in our platform behind, starting from facade to elevator and escalator, chillers, fire safety, plumbing and drainage, energy, plant room, etc., etc. Give you a full understanding of what's happening in real world. Oh yeah, we have just shown it. This is actually the digital twin that I've just shown. And to work out the ICC is a very comprehensive technology, starting from facade. You know, around 40% to 70% of the operating cost coming from air condition. So if you tell the building owner where you're going to save the air condition because of the leakage in the external wall, you're actually saving the pennies for them. So it's actually very helpful. Now, no one can tell which glass panel got leakage of air conditioner. No one can tell. But by means of the respect technology, now we can tell them, you know what? Here is the major leakage of the air condition. You can fix it, apart from like water leakage as well as the air leakage, the air condition. Very expensive. The second one is, of course, safety. Right? Curtain wall, we experience so lot, especially after typhoon, right? The glass panel just got dropped, or like the lamination from reinforced concrete, they dropped those tiles. Very important. About the elevator monitoring, we perform a comprehensive, including wire, the rope of elevator as well as the bearing, the electricity, electric current, the positioning of the elevator. So that is to give the elevator company a very comprehensive understanding and condition of the elevator in AI way. And also the machine performance that I've mentioned about the water system, to give you a whole picture in facility management, inspection and monitoring. So that's what I've shared before. It's like it's quite scary, but it's actually happening. I cannot tell it's every day, but it's quite often. You can see this is in sunny day. It's not in typhoon season. It's in sunny day. Right? Can we do it in a safety way? Less risky? Yes, we can. And we have to enforce it, right? We have to enforce it because this maybe our family, maybe our friends will get involved. We have to make it happen together. So I've just mentioned this one. So kind of this is the the Respect platform that we give to our customer, they can see, hey, you know, this elevation in my building, we got this problems, and the security, what's happening over there. You can see everything in one go instead of PDF flipping, right? If you employ the surveyor, they give you 100 pages, 200 pages of PDF, and then, you know, what is that? But this gives you a very, very good representation, visualization of the buildings that you are living in. Because be reminded, every one of us are either in either one of the building 20 hours a day. Either way, we are sleeping, we are working in office, we are shopping, we are eating in restaurant. This is very important. In fact, every one of us, our daily lives. So, yeah, elevator I've just talked about. We use the visual high-speed camera with AI to understand the raw wire, the rope, which we have deployed in Swire, EMSD headquarters, ICC, etc., etc. And also by using the magnetic wave that I've just shared. We understand the magnetic flux so that we know what are the defects happening, the severity, etc., as mentioned. And by using the vibration technology, we interpret the wave. So different wave patterns, which behind the scene is actually represent a failure course or failure route mode. So we understand what's happening, like one peak and followed by two small peak and another sharp peak. What does it mean? We understand that so that we can tell you the root cause. What does it mean? Instead of just like a threshold deviation, it's not that. Like yesterday is this pattern, today is this pattern. Oh, you have to go and have a look. But what does it mean, right? So many IoT company just tell you this. And then you better find the SKF, which is the bearing partner, to look for the root cause. But we are not. Because we can actually tell you, we understand those waves and those patterns, we can tell you the exact failure. And whether you need to repair at once or right now, immediately, or is it just like, what is the failure mode of that? That is a very important differentiation between just a IoT company and Respect. Because we are one of the domain expertise in those areas with AI. That is the cloud platform, the ACE platform, actually, for the elevator monitoring. So to understand the rope, the bearing, the current, etc., the trend, right? Stage 1, 2, 3, 4. So give you what's happening on those alerts. And machine monitoring, about the chillers, we understand again the the current, and also the bearing condition. So give you, this is stage 4, outer race fault, or what is the electric current happening, the condition, the portfolio, right? To give you extend the lifespan. That is a very important piece. To make you predictive, to understand, to have a visible in future, instead of just the current snapshot, you can plan. You can do something more to protect yourself and your family and your friends. So that is a real-time analysis. Because we understand what's happening, that's why we, in our team, 75% of our company or our team are in R&D and in those domain experts area. That is to like work out the AI technology for this system or building components. Yeah, that is just to give you a summary what I have just, or what we have been doing in Respect. From facade, external wall, to internal, like E&M, elevator, escalator, the plant room, switchboard monitoring, energy monitoring, to give you a comprehensive understanding of the building condition, safety and reliability of the building performance. Thanks very much. I'm Harris. Thanks for sharing. Thanks for having me today.
Thank you,
and
Mr.
I
Sun.
look forward to talk to you soon. Thanks.
Please remain on the stage. Thank you. May I invite Dr. C.H. Ng, Chairman of HKEIA, and Professor Yong, Professor Winkle Yong, Center Directors of CARES, yes, for presenting the certificates of appreciations to Mr. Sun. So, okay. May I also invite Mr. Tang and Dr. Zhang to come on the stage to have a group photo. Thank you. So please be seated. Ladies and gentlemen, there is now a break of 10 minutes. Please take your personal belongings with you when you leave. When you come back after the break, we will have one more presentations and a Q&A sections in this afternoon. If you have any questions to raise for speakers, please drop it down and raise during Q&A sections. The conference will start after the break at around 3:10. Please be seated. Our next speaker is Dr. Charles Zhang, Senior Data Scientist and Deputy Director, NVIDIA AI Technology Center, Hong Kong. Dr. Zhang will speak on the topic of NVIDIA GTC 2021 Spotlights of Advanced Manufacturing and Predictive Maintenance. Let's welcome Dr. Zhang.
Okay, good afternoon. Okay, thank you for inviting me to give a presentation here. We are a strong partner with CARES. Okay, today my presentation will be separated into two parts. For the first part, I will give an update of our GTC, our biggest event last month in our headquarters in Santa Clara. And then for the second part, I will give you some use case of how to use AI for predictive maintenance. Okay, before I start, I will play a videos of our GTC's summary of. Okay. In fact, this is an introduction video of every year's GTC. In this video, we collect several AI applications in different areas. And in fact, this background music is generated by AI models.
I am a creator. Blending art and technology. To immerse our senses. I am a healer, helping us take the next step. And see what's possible.
Wow. Can you really see?
Yes. I am a pioneer, finding life-saving answers. And pushing the edge to the outer limits. I am a guardian, defending our oceans.
Roger that. Fly by inbound.
And the magnificent creatures that call them home. I am a protector, helping the earth breathe easier. And watching over it for generations to come. I am a storyteller, giving emotion to words and bringing them to life. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Okay, so this is the introductions of our GTC, and in fact we have more than 1,400 different talks in our GTC. So if you guys are interested, so you can just go to our website to take a look. Okay, so I will spend a few minutes to give you some new technologies we announced this year. Omniverse, for the first one, the Omniverse. Omniverse is a simulation platform for you guys to do a 3D visualizations or some animations creating. So you can just think of it as a okay. For the first one, it enables the developers to do a collaborative development. Okay, because we can have a centralized server, we call the nucleus, and then different developers in different locations can collaborate with each other on the same projects. For example, some people are doing some drawing on the kitchens, and some another developers maybe doing some developments for the bathroom. Okay. And then it also enables you to connect with the existing, most of the existing software, such as the AutoCAD, SolidWorks, this kind of commercial software. Okay. So why we create Omniverse? Omniverse is just a platform for you guys to do the simulations. And this is a use case. We partner with BMW. BMW use our Omniverse to create digital twins to build their factories. In fact, these factories is they use the digital twins to plan the whole factories, and also the AGVs, the autonomous vehicle, and also different predictive maintenance modeling in this car manufacturing factories. So yeah, so this is one of the use case we are partnering with BMW. And also we are announcing a new product. We call the Bluefield 3. This is a DPU, data center processing unit. Because in nowadays the data center more workload on the data center, and because this is a software-defined data center, and we want to offload the CPU. Okay, most of the jobs from the CPU, we want to offload in the CPU, so that CPU can have more capability to running more services. So we put all the storage and networking compute to the DPU. In fact, DPU is another name of our next generation smart NIC from Mellanox. Okay. Okay. Large scale AI models. Because when you heard of some of the computer vision models, such as the AlexNet, ResNet, it is quite good at doing some computer vision tasks. But when you want to use some language model, such as doing some language translations or some question answering system, and then the language model is a very huge, very big model that you need a very long time to train it. And NVIDIA, we invent a new language model. We call the Megatron. Because OpenAI has a Megatron, OpenAI has a language model we call the GPT-3. And then Megatron is 10 times larger than the GPT-3. Okay? And we can do the inference and the response in 1 second with 16 query. And when compared to the dual-core CPU server, you will take 1 minute to get the response. So this is how we invest the GPU technologies to try to achieve the real-time response. Because we think that 1 second response for a, let's say, chatbot which is sufficient, which is also reasonable. And because of that, because we have a very large AI model, want to train it, the current situations to train this kind of large AI model is the data movement. Okay, because for the existing technology, we need to move the data from the system to the GPU for the computations. And then now we are using the PCIe 4 Gen 4, which is the bandwidth is around 60 gigabytes something. Okay, so this is a bottleneck of training very large scale model. As I mentioned, Megatron is a very huge AI model. This model is trained in our own data center. We use 3,000 GPU to train it. So we found that the data movement is a bottleneck. So that's the reasons why we are announcing this new AI specific CPU. Okay, this is CPU. NVIDIA is making AI chips for GPU AI chips, but we also making a CPU for the in the futures. Okay, so we will release the NVIDIA CPU in 2023. Okay, so this is our roadmap. We are not trying to replace existing architecture, existing CPU architecture. This is the specialized AI chips for training very large model. Okay, the bandwidth between CPU and GPU, okay, is 900 gigabyte per second, compared with the PCIe, which is getting 64 something. Okay, 900 versus 60 something. So this is our roadmap. Okay, you can see that we are having an Ampere architecture. 2 years later, okay, next year we will have a new GPU, the Ampere next GPU, and then we also have the Bluefield 3, a new data center processing unit. And in 2023, and then you can see we are announcing the CPU, the Grace CPU. Okay, this is our roadmap. Okay, so this is the summary of what NVIDIA do. We are building the chips, okay, for supporting different applications, and also we are building the software stack. You can see this is our SDK, CoolIO for the I/O task, and CoolDF for some ETL ETL, that means extract, transform, and loading task in data science. That means the pre-training, the data engineering pipeline. And we have supporting the AI, cuDNN, and cuML for machine learning, data science. And also, for each of the applications vertical, we also have different platform for that. We have the Omniverse for the simulations, and also the digital twins. And we have a cuQuantum. We have a SDK for helping the quantum computing researchers to do the quantum simulations. And we have the Morpheus. Morpheus is a newly announced SDK for the AI security. And we have Jarvis. Jarvis is a conversational AI platform. We have a Merlin. Merlin is a recommendation system for the retail and for retail industry. And Maxim is a very interesting SDK for the video conferencing. Okay, Clara is for healthcare. Metropolis is for smart city. And also Ariel is for 5G communications. And ISAC and Drive is for the robotics and autonomous vehicle. Okay. Okay, just finished the first part. The second part, I will try to share with you the use case of using AI for the predictive maintenance. Okay, okay. What is predictive maintenance? I think most of you is already know that, but I think okay, because ASM have the expert here, and yeah, and also okay, what is predictive maintenance? Predictive maintenance, because we want to know we want to avoid the downtime of a particular system, okay? Because if we can know ahead of the failure, then we can plan the replacements or the repair, so that we can avoid some suddenly downtime, okay? So this can reduce the maintenance costs and also extend some operational life of the capital equipment. Okay, so this is the reasons why we need predictive maintenance. Okay, so basically there are a few applications in the predictive maintenance. For the first one will be the anomaly detections. That means we have the machines. We want to detect whether they have some anomaly. For example, there's a time series of data of some, let's say for the voltage, and then we can say, suddenly today we find that the voltage is different compared to the previous time series data. Then we may find that, okay, we may think that this may be some anomaly here, so we need to do some inspections. So we need to build some model here to detect such anomaly. Okay, so and also the anomaly classifications. And the second one is the usage at the lifetime. We want to predict the lifetime of some of the machines or the equipment. Also, we want to work on some work scope optimizations. And okay, so this is one of the use case. We are working with our partners. This is a startup company in US, and they are working on trying to building a model to predict the useful life predictions. And okay, so this company use a NASA engines data set to train a deep learning models. And with these deep learning models, you can see that a accuracy improvement of around 33% to 50% can be seen compared to the traditional methods. And also, Yeah, in fact, in our NGC, we have a NVIDIA GPU cloud. You can, if you are interested in this use case, we already put some demos on our website. You can just download it and play with it. Okay, as long as you have a GPU on your machines. Okay, because you will download the model and all the code, and then you can run the testing. Okay. Okay, so this is another use case, trying to predicting some impurity of the iron. Okay, we need to collect some data from some of the sensor, okay, such as the airflow and the input amount, the pH levels, densities, and other snapshots that the manufacturing process, during the manufacturing process. And then we use because this is a time series data, we need to use some deep learning models to train this deep learning model using this set of data sets. And then the result, we can see that successfully identify 90% of the impure batches of the iron based on these manufacturing data. Okay. So, okay, what is the advantage here is that traditionally, we can use the traditional methods, the traditional machine learning methods to build a model. But nowadays, with the help of GPU, NVIDIA GPU, we can train a deep neural network, which is a better performance or in terms of the accuracy, and also and also with the help of GPU, the processing time, the inference time can be attained to in real time, really real time. Okay, so this is another use case. We work with our partners. This is the oil and gas market in US. And what is the challenging they are facing is that their infrastructure is quite old. Okay, 42% of their infrastructure is nearly 15 years old. Okay, so this is very easy to have some failure or some downtime. And the second one is that the aging workforce, 50% of their of the worker or the inspection worker will retire over the next 5 to 10 years. That means the lack of labor to doing the inspections. And then the third reason is that unplanned downtime which is very costly, okay, to the company. So it costs the US to refine $6.6 billion US dollars in margins each year. So this is the three major reasons why we want to build a predictive maintenance model to avoid unplanned downtime. Okay. Okay. Because we have many data, we have many sensors to collect different source of data. Okay. And you can see that for the pipeline inspections, for each 600 kilometers, you have 1.5 terabytes data. For example, you have imagery data or video data. And for the ultrasound, that will be around 1.2 terabyte data per 8 hours. That means you will have an ocean of data. But for traditional algorithms, such as the machine learning algorithms, only 95% data never used. You pick 5% of the data to build your own model, and these 5% of the data may not be very good may cover the whole picture of the data distributions. So, so there's the reasons why we may need to use the deep learning, a new computing algorithms to jump in to help to increase the accuracy or the performance of the modeling. What is the difference between deep learning and traditional machine learning? And in fact, deep learning is also a machine learning model, okay, but a very specialized machine learning model, because this is we call the deep neural network. Deep neural network is also a machine learning model, but because this is a very deep, that means we have a very large number of layers of the neural network inside the model, and then the deep neural network requires many data to train firstly, and secondly require a large amount of computation to do the training. Okay, and okay, what is the advantage of the deep learning based predictive maintenance model? As I mentioned in the previous slide, we only use 5% of the data. 95% of data are wasted. But because we don't want to spend so much time to do the feature engineering, data cleansing, and then but with the help of deep learning, okay, deep learning can have the capability to self-learn the features. Okay, you just need to we assume the data is already cleaned. Okay, and then you just need to input to the deep learning model, and then the deep learning model will automatically generate some feature extractors, so that we can use these feature extractors for some classification tasks or anomaly detections. So this deep learning model can benefit from the large volume of the data, and so that the performance can be further improved compared to the traditional machine learning algorithms. And yeah, you can see that this is the curve. For the traditional learning algorithms, when the number of data getting more and more, the performance will somehow converge or plateau at some certain level. But for the deep learning model, you can see that the performance is higher than the traditional machine learning algorithms. Okay, so industrial access also needs the AI to build a model to avoid the downtimes. And this is another use case for the. You can see that this is some data about the temperature profile, and you can see that for the blue curve, this is the performance or some metrics about using traditional machine learning algorithms. But with the deep learning methods, you can see that the performance, this is in red, and which is much better than the old methods. And you can see that 5 times faster detections of the anomalies, and 50 times faster the model training, because with the help of NVIDIA GPU, and also 100 times for the data utilizations at the source, because we have a data science platform we call the Rapid for you to do the data analysis. Okay, so predictive maintenance tasks will be like this. This is the pipeline. First, we have oceans of data, petabytes of data, the raw data from the sensor. This sensor will most likely the time series data, and such as the voltage, some vibrations, or some magnetic flux data, so on and so forth. And then we need to do some data cleansing and data tagging. This is quite labor intensive, I would say. Once the data is cleaned up and annotated, and then we can start the model training. That means we can build machine learning models or the deep learning models. And then, once you think that the model is good enough, then you can start to deploy. But you need to retrain the model with some newly collected data, because the data distribution will change time by time. Okay. So in order to maintain the good accuracy, so you need to recalibrate the data. Okay. Even you have already deployed the model, let's say for every month. So this is the cycle of the whole predictive maintenance workflow development, starting from labeling data, and then train a model, and then fine-tune a model. That means also still a modeling process. And then you can deploy it for reference, for inference. And then even you have already deployed your model into a production environment, you need to do the recalibrations. That means you need to recollect some new data, and then retrain or fine-tune your models. Okay? So this is a long-term workflow for the whole AI development. Okay, so for NVIDIA, we have different products supporting different workflow. Okay, for the deployment, we have some embedded system, we call the Jacksons, for running some inference task, and then for the model training, we have a workstations, we have a data center server for building your model, and then you will train the model in here, and then port it to the embedded system for inference. Okay, so I think, this is also another use case. We partner with this company, okay, for building some predictive maintenance applications. This use case or demo, you can get the demo from our NGC, ngc.nvidia.com, and then you can just grab the whole model and hold the data, and then run it and fill it. Okay, because we're running out of time. This is the dashboard of this startup partner. They are building the predictive maintenance dashboard and the model for the anomaly detections. Okay. Okay, I will just skip this. Okay. So yeah, this is the same company detecting the oil wells. Yeah, the deep learning models, 93% detection accuracy with 2 months lead times at 5% false alarm. Okay, and at 10% deep learning based anomaly detections can yield 300K per well of the lost productivity annually. Okay, so this startup company built a very good job for helping the industry to doing some preventive maintenance. Okay. Okay. This is the last slide. NVIDIA, we have different content for the predictive maintenance. We have a deep learning institute. In this, we call the DLI. We have a online course which is teaching you how to build a predictive maintenance model starting from scratch, from data collections, and then model cleansing, model pre-processing, and then model training up to the model deployment. Okay. So you can just take a look at our Deep Learning Institute. And then we have NGC. as I mentioned, this is our NVIDIA GPU cloud. We put all our resources onto this website. You can download whatever SDK or demo from here. This is all free. Okay, you just need to donate your email address to register an account, and then you can use it. Okay. Okay. Thank you.
Thank you, Dr. Zhang, for your sharing. Please remain on the stage. Thank you to all the speakers this afternoon for their great and inspired presentations. I would like to invite them once again on stage for Q&A sections. Mr. Tang, Mr. Sun, and Dr. Zhang, please. We are pleased to have Dr. Jeffrey Chan, Program Manager of CARES, to be our moderator. Dr. Chan, please. I will now give the stage to Dr. Chan.
Okay, thanks for sharing, and I think the presentation is very insightful and also the informative. Thanks, Harris, Jeff, and also Charles. So it's good that to know that AI has already developed and also implemented in different kinds of applications. And thanks for sharing. So now is the Q&A sessions. If you have any questions, you can raise your hands and also state which speaker you would like to ask questions. Okay, so yeah, we have got one.
Hello, I'm Dennis from CARES. So my question may be direct to maybe Harris, because in the past, people used to think that AI is a little bit fuzzy, right? Okay. So when we are applying AI in maybe safety and reliability, like the lift or the wall, building walls. So they may be a bit skeptical of using AI in detecting those anomalies, right, or failures. So how would you convince the industries to adopt AI in this kind of applications?
Yeah, that's a very good question. Thanks, Dennis. You know, we are in the transition stage, right, from traditional to AI-powered world. But the way back that to convince our customer or the owners or whatever stakeholders, we have to work it out into also work in a hybrid, I would say hybrid mode. That is to adopt the traditional way as well as the AI-powered. How do we work it out? That is, at one side, we provide the AI analytics and analysis for the predictive thing that I've just mentioned to them. At the other side, we have the engineers, chartered surveyor engineers to verify what we have done to them. So it's actually working in parallel to our customer, because to them is nothing less compared to the traditional results, because all those reports and analysis has been endorsed by chartered engineer or surveyors. So, and also give them one more that is a convincing or promising endorsement from the professional, as well as we can save the cost and time from them. So it's like kind of working in a parallel hybrid mode.
Thank you, Harris. So any other questions?
My name is Sasan, also from CARES. Depending on regarding my background, I have worked in corrosion, material science, as part of my project in bachelor, and I've always been interested in this field. Dr. Chung, the last presentation just talked about the oil industry and how we can use AI for monitoring faulty machineries or faulty parts in oil and gas industry. Is it also applicable to corrosion? Because in pipes we have pits, we have holes, cracks that form over time in pipelines. So is AI applicable for detecting these kind of defects, which are very catastrophic and they cost billions of dollars for that industry to deal with the failures?
Okay, thank you for your questions. Are you asking that can we just doing some inspections or for the pipe, right? The pipeline,
and
right?
prediction, yeah.
Yeah. In fact, we have some use case in US. They are using some drones to capture some videos and some image, and then doing some inspections. Yeah, we have this kind of use case with our partners in US, and this is applicable. Because for this kind of defects inspections, we will use some videos or some image for the detections, and then which may not be suitable for some predictive. Maybe if okay, as long as we can using our bare eye to check whether it is we found that this equipment will have some crack in the next 2 months, and then we can also still based on some computer vision model to set up or to build such kind of the predictive maintenance system. But I think most of the time, computer vision's model we will just doing some inspections instead of the predictive maintenance. Yeah.
Thank you so much.
Thank you, Charles.
Hello. In terms of reliability and predictive maintenance, may I know how to select the sensor to be installed in ASM equipment for conditional monitoring, and how to choose optimal installation location? Thank you. Mr. Jeff, please.
Thank you for your questions. As I said before, we have particularly choose the component related to the bonding qualities. So all the related modules are already identified. And actually in our control system itself, it is already all those parameters are already collected in the central controllers. Just a matter that we have to collect the data back to the AI servers without degrading the performance of our machines. So that we have to additional another equipment which tap to the machines to check those data from the controllers itself. So that actually right now we didn't have to no need to add additional sensors to the machine itself. But I would say right now we can identify, as I said, 70% of the common issues only. So in the coming days, we still working on how to increase that percentage by additional sensors, and even those the networking we are using. Right now, the neural network itself is non-domain knowledge. No, you don't have a feature. We didn't do some feature extractions before we fit into the network. So in the future, we may consider to add some just like the facial inspections. We do some convolutions before to fit to the neural networks, so that increasing the capability of the neural network. Yeah. Thank you.
Thank you, Jeff.
I'm Tom Chen from CARES, Program Manager. I have 2 questions. I'm a little bit greedy and want to ask 2 questions to Charles. The first one is, Intel dominate the Xeon processors for server. And I saw the Grace processor ARM core going to be market available in 2023. Why NVIDIA put a server processor in the roadmap, which I'm a little bit skeptical, because for it's pretty proven that x86 processor is dominating the server side. And according to, which remind me one thing that I heard this morning from Professor Cho, talking about the distributed computing, which talking about the edge processor. The second questions that I have is why NVIDIA is not focusing more on the edge processor side, but trying to put a CPU in the server side, which is even ARM core, not x86 core. That's the two questions that I have.
Okay,
Thank you.
Okay, thanks for your questions. In fact, we do put a lot of resources on the edge computing. For the AI model, for the edge computing, we have two different form factor. For the first one will be we have a series of embedded system. We have Jackson Nano for the beginners, and then for the Jackson AGX Xavier. Okay, all of these embedded system are equipped with ARM CPU, ARM architecture, and then one of the advantage of using ARM CPU is the power consumption is quite low, which is suitable for the edge computing. And another form factor is for the data center. Okay, that means we still use the data center for the edge computing or the inference processing. That means we may have some smart sensor, for example, smart camera collecting the data and then transfer back to the data center for the processing. Okay, so we have this. We spend a lot of resources on the edge computing, and also we in fact we have a platform we call the feed command. We have a web portal. In this web portal, you can trace all your health status of your edge device, no matter data center server or the embedded system. Okay, you can track all the health status. You can control it to attach to the cluster or detach it anytime. Okay, we have this kind of product. Okay, then referring back to your first questions, because we invented NVLink. I think 5 to 6 years ago, NVLink is trying to setting that is a bridge between GPU and GPU. We let them to communicate directly between GPU to GPU. We don't need to transfer the data back to the system from the first GPU and then transfer the data to the second GPU for the computing. Because AI models are getting larger and larger, then we need to use a multi-GPU, even multi-nodes. That means, let's say we use 16 different servers, and each of the server have 8 GPU to train a single model. And then for training this kind of model, we have several kinds of methodology. We have data parallelism, also a pipeline parallelism, and model parallelism. And if the model size is not that big, we can still use the data parallelism. That means you can train, let's say, if you use 8 GPU, then you can build 8 identical model, and then with inputting different data, and then aggregate the result and averaging the result for the training. This is data parallelism. But when we have a very large model, as I mentioned, the Megatron, 10 times bigger than the GPT-3. GPT-3 is consisting of 175 billion parameters. That means our Megatron is 1,000 something billions parameters inside a single network. We cannot just put this single network into a single model. We need to split it into several parts and putting into several GPU, so that GPU and GPU communication is very a very crucial step. And also, when we need to train this large AI model, the data transfer, we need to transfer data from the system to the GPU for the computations. And because data transfer is also a bottleneck for the existing architecture. So this is the reasons why we need to invent a new GPU using the ARM CPU, ARM architecture, and enlarging the bandwidth between CPU and GPU. We are not trying to compete with the x68 market. We are still supporting the x68 CPU, but this ARM CPU we got the Grace. Grace is a AI specialized AI chips for a very huge model, because nowadays language models are pretty big, pretty huge. So we need a specialized infrastructure so that we can train it efficiently. And we can foresee that with the help of Grace CPU, the speed up will be around 10 times compared to the existing DGX 800 system. Okay, so this is, yeah. I think yeah, okay.
Can your questions be answered?
Yeah. The ARM core CPU, I actually worked in Intel before, and ARM core CPU server CPU has one of the issues. The computation power is less than x86. I understand what you're talking about in terms of the size of the model, or the corpus might be too big, that you got a lot of the parameters. And ARM core server CPUs suffer from one issue, which is the computation power relatively, with the same voltage, less than the x86 core, which I don't know. I don't know, but I guess you guys are optimized the CPU and trying to put it in the AI application. That might make a lot of sense in that case.
Yeah, because we are trying to, okay, GPU is not replacing CPU. Okay, first thing, GPU is trying to, okay, you can put some of the tasks, okay, from CPU, to pass it from CPU to the GPU and let the GPU for the computations. We put the most compute intensive tasks to the GPU for the computations, so that we offload most of the workload from the CPU. This is also another reasons why we invent DPU, data processing unit, because for those networking and storage, nowadays we still use the CPU for the computations, and then we foresee that in the next generations, in the futures, data center infrastructures, those workload will be handled by our DPU or the smart NIC, and CPU will do not much task. So I think this may address your concerns about the computational power compared to the x68.
Okay, thank you, Jeff. So any other questions for the remaining two speakers? So if no other questions, I have some questions. For Harris, maybe. As you mentioned that you use drone for the building inspection. So may I ask, is there any safety concern of the drone itself, and also maybe the some limitations by using the drone, especially in Hong Kong, for the performing the inspection?
Yeah, sure. It's I would say this is a very typical topic or questions by using drone, right? Just like without drone, we can think of like what do we do nowadays? They use gondola, right? Even you must have seen some like videos, just like the videos that I've just shown. This is also something that's about safety issues or concerns that if we impose those risks on those inspection tasks. Drone is, I would say, is much safer in terms of, because we have like parachute when we do inspection without control, like let's say out of control, it's like have anti wind resistance and sense avoidance thing compared with gondola or scaffolding, right? So this kind of measures that we are not doing the hardware itself. Basically, we are doing the AI stuff. But I would say robotics and adoption in either way of inspection or monitoring is definitely the trend, and how we put the risk management to make a compromise or to make a proper measure for safety.
Thank you. So, any other questions?
I have one question. I come from CARES also. And then I could also ask the Jeff, since it seems that we're leading manufacturer like ASM has applied the AI technique on the wire bonding machine, such as bonding process. It's very exciting. And then I want to ask that for the AI and then control, traditional control, can we combine these two together to make a more prognostic, and then for a optimum control to control the machine for a good bonding process, or some optimize the machine performance? Can we combine these two? How to combine these two? Maybe this is a very good approach for the right now industry to advance its control techniques. I mean, it's
thanks for your questions. When you talk about the control, are you talking about the motion control or the
I mean, all control maybe maybe we can combine traditional control, just use the PID.
I see.
And then how we control PID control with the AI control.
Your idea is very inspired.
Yes.
So what we're talking about is about the motion control, how fast we having the motions from one point to one point as fast as possible, using and stable as fast as possible, right? So right now we are using some look forward algorithms so that we can predict the vibrations, and then we do the motions particular to those characteristics of that mechanical characteristics. So I would say our control team right now is using their knowledge to know how to have an optimum setting of those parameters. But your suggestion is very good directions. So we back to our R&D office to take a look whether we can using AI maybe have a better solutions in the future. Thank you for your suggestions.
Thank you, Jeff. So is the time over, or we still have some time now? No?
Time's up.
Okay, time's up. So thanks for sharing, and we may talk more after this session. So now I pass the stage to Jen.
Thank you, Dr. Chen, and all our speakers. Please be seated. Thank you. Thank you for our speakers. Ladies and gentlemen, at this moment, we are very honored to have Professor Winkle Yung, Center Director of CARES, to be here with us today to offer a closing remarks before we end this seminar. In the meantime, would you please fill the questionnaire in your gift bag and leave it to our staff? Thank you very much. Professor Yung, please.
Dr. CHM, distinguished guests, ladies and gentlemen, it is my honor to give you a closing remark for this successful technical seminar on artificial intelligence transforming products and impacting safety and reliability. I'd like to highlight some of the important messages that we learned from our speakers in this morning and this afternoon. In the morning session, we call Dr. Hu. He shared with us the interesting topic, how safe is AI? We never asked this question before, right? And it's a very interesting topic, how safe is AI? And the second speaker, Professor Edward Chung, he shared with us the traffic volume estimation and prediction using Tokyo as a case study, and that will be equally applied to Hong Kong. Professor Chow, he shared with us about AIoT, which is the way to go in the next 5 or 10 years, and how edge computing can help in this regard. In the afternoon section, we have Jeff from ASM sharing with us how predictive maintenance are being implemented in real-time, real-term in advanced manufacturing company like ASM. Then we have Harris from Respect sharing with us about AI inspection, which is so important to smart building, which is a very critical part for smart city. Last but not least, we have Charles from NDA sharing with us about deep learning models in predictive maintenance with RUL prediction of machineries and many applications. All in all, these topics contribute a lot in enabling Hong Kong to be a smart city, and they are so critical to brand building for Hong Kong. We hope by co-efforts between academia and industry, we can do a brand building for Hong Kong. In other words, whatever design in Hong Kong, whatever built in Hong Kong and test in Hong Kong, no matter its component, products, and systems, they are of #1 reliability and safety. And that is the mission of CARES. CARES has organized 3 webinars in past months. Added to that, this successful technical seminars is another demonstration of our very close collaboration between CARES and our industrial partners, including collaborating companies like ASM and Westpac, including supporting organizations like Hong Kong EIA, including our technical collaborator like NVIDIA. My special thanks also go to all speakers and guests of honor, Dr. Ng, today, giving us a welcoming remark. And particularly, I want to give thanks to all participants today, no matter it's in the afternoon or in the morning. I know that you are very busy, and I thank you all for taking your valuable time to attend this seminar and to share with us what your interests are regarding safety and reliability. In closing, I would like to take this opportunity to thank all our collaborating companies and enterprises. You will see a full list of them outside this room. We have a banner with all these logos are. And I'd like to thank also our supporting organization, our mask sponsor, for their participation and contribution, as well as our CARES professional team for their excellent arrangement in organizing this technical seminar. I sincerely hope you have enjoyed the seminar today. For those who registered for lab tour and interactive showcase, please assemble outside this hall right after this remark. Thank you for your participation and have a good evening. Thank you.
Thank you, Professor Yong. Please be seated. Again, thank you all the guests and participants for joining us today, and a huge thank to all our speakers, collaborating organizations, supporting organizations, and mass sponsor for supporting the seminar. We could not have put together such an inspiring and engaging event without you. I hope all of you found the seminar beneficial and valuable and had the opportunity to meet and chat with our professional speakers. It's been my pleasure to hold this event and hope to see you all again soon. I wish you all a pleasant and healthy every day. Thank you. For those who registered the afternoon lab tour, please wait at the receptions area. Thank you. Last but not least, don't forget to get your CBD certificate for the afternoon sections at the receptions. Then, see you next time.
我哋會透過一啲 IoT 嘅 sensor 去攞一啲即時嘅數據嘅喺 reliability 上邊。Data driven PolyU 同埋馬里蘭州大學嘅 professor， 譬如Professor Yong 啦，就係我哋嘅 data center director 啦。咁Professor Michael Patch 咧就係我哋嘅 head of the research 咁樣嘅。咁呢部 supercomputer 係DGX A100。咁咧我哋呢部暫時嚟講咧，呢部喺東南亞咧係最快嘅其中一部 supercomputer 啦。咁佢裏邊有8粒 GPU， 所以你見到譬如呢個係一個 dashboard 嚟嘅。咁而家 connect 住 remote control 住 remote connect 住一個 PolyU 嘅 supercomputer。咁你會見到佢 GPU， 譬如呢啲就係代表每一個 GPU utilization 嘅情況。咁佢有一個 function 嘅，譬如因為我哋做 reliability 同 safety 嘅 research 好多時咧都會有一啲好大量嘅 data 去到 TB 或者以上。咁我哋會有一啲 function 啦，呢部supercomputer 可以去 NVLink 啦。咁佢哋之間嘅 GPU 咧其實可以有啲 communication 嘅，咁就令到嗰個 machine learning 嘅時間係更加快。係實時嘅。係實時嘅。咁譬如我哋呢度睇緊個時間啦，大家可能4點35分啦，其實佢就 monitor 個 data。咁呢個係一個實時嘅狀況啦。嘅概念上邊咧係好重要嘅。咁呢個係其中一個 illustration 俾大家睇啦。其實大家後邊咧其實有一個model 嘅。咁呢個 model 咧其實就可以係一個 AR model， 即係話你見到個 model 就 scan 到喺呢個位。譬如我其實個概念咧就係一個 interactive 啲，大家可以feel free 咁去玩下 wireless 嘅一個技術啦。咁佢可以應用喺一啲外牆維修上面啦。咁有啲咩事，如果有個 detection 或者我哋可以透過啲數據做一啲 predictive 嘅 model， 就會喺度幫助到成個 smart city 嗰個 development。咁有興趣嘅朋友可以揾多幾個嘅，呢度 scan 嗰個位都可以撳一撳就 OK 嘅。
撳呢個？係啊。撳。
我呢個唔係撳呢度。
係啊，撳呢個位就 OK， 其實係 scan 嗰個位嘅啫。
呢度係啊，再撳。係啦。
咁啊，譬如一個 smart city 喺我哋依家幾年咧，你見到佢發展，但係我哋一個好重要或者呢個 centre 好重要嘅地方就係要發展個 reliability 就係 smart city 嘅 development reliability 都好重要。
呢個機組上邊咧，我哋用咗 FMEA 呢個方法啦，用個 predictive mode 啦，同埋又所謂 failure mode 啦，同埋 mechanism 做一啲 predictive 嘅嘢。咁中間嘅方法咧，當然我哋要 install 唔同嘅 sensor 喺度啦 hydraulic oils 嘅。咁啲 hydraulic oil 入邊有啲唔同嘅 chemical 嘅 residue 喺入邊嘅，咁我哋就分析入邊嘅 residue 嘅成分，咁同埋進行一啲用一個物理方法啦，用光學顯微鏡啦，分析入邊嘅 image 啊，有啲咩唔同嘅分佈啊，從而評估翻佢入邊嘅 residue 嘅成分。咁第二個研究方向咧，我哋就關於個巴士嘅。咁巴士我哋有兩種唔同嘅研究嘅，住去做一個 model 嚟分析，咁參數有咩 anomaly。咁呢啲都係一啲 predictive maintenance 嘅其中一個我哋好重要嘅發展嘅方向啦。咁啊再嚟啦，咁啊跟住下邊呢個就飛機嘅拖機啦。咁我哋會進行兩部分去睇嘅，會睇個 POF 啦，睇佢有啲咩 failure 嘅 symptom 啦。另外一部分我哋會喺生產線注塑啊嗰陣咧，唔同嘅 process parameter， 咁啊兩部分一齊做啦，分析。咁睇到一啲譬如 anomaly 出現咗嘅話咧，咁啊進而都係做一啲可以 predictive maintenance 嘅方向。咁呢啲都我哋要通過唔同嘅分析嘅方法啦，包括一啲 Adversarial Learning 啊，一啲 simulation 啦，咁去 identify 到嗰個 water tree 嘅 formation。咁呢個都係我哋一啲研究嘅方向啦。
我哋有兩個 lab 嘅，呢個係1、2、1，我哋仲有一個10W，即係我哋有三大份嘅嗰個 equipment 嘅，一個係 temperature and environment testing。Another one 係 life cycle assessment 嘅，到第三我哋要再到一部 chamber 咧，就可以兩個 chamber 一齊用嘅，係咁嚟。所以就 another equipment 叫做 machine fault simulator， cycle。所以呢啲係差唔多125 micron 嘅呢啲 fiber， 所以我哋放入 pressure control， 同埋 humidity 係10到98%嘅。所以而家係我哋做過一個實驗啦，而家係我哋呢個 area 咧，我哋 actually 叫做 battery life cycle assessment。That means 我哋係用我哋去 check 下 battery 嘅condition。所以而家你睇到入邊有個 alkaline battery 嘅，所以咧我哋點樣做咧？我哋係放啲 fiber optics 或 FPG sensor 啦上去alignment 嗰個 bearing 啦，嗰個 belt 啦，呢啲可以去 run 幾多個 cycle 咁嚟做。500M 嘅，所以 D 部都可以到1500M 嘅，係，所以 D 部係有個 curve tracer 嚟 measure， 所以你可以你嗰啲 component 嘅 spec 啊， D 部機可以 check。can hold it。好。Thank you。如果冇就有其他。Sorry。